and gentlemen, welcome to the opening ceremony of the first International Conference on Software Engineering and Information Technology, ICoSEIT 2022. I'm Yen Hamida. It's such an honor for me to serve as the master of ceremony for today's great session. Ladies and gentlemen, before starting today's event, we would like to encourage every one of you to make your most comfortable position as you are going to witness the great session in this event. And we also would like to announce a very important information regarding to the virtual conference instruction. Ladies and gentlemen, this conference is conducted to be in listen-only mode. So by default, all of the attendees are muted by the organizer, as the organizer would like to make sure this conference conducted smoothly and productively. Following the keynote and tutorial session, there will be question and answer session led by the moderator, and you are welcome to deliver all of your questions during the session by typing it on the questions box. We realize there might be a limited duration to the question and answer session, but would like to make hard the moderator will deliver the supplementary question based on the first question submitted. And we also would like to announce that this event is being broadcasted live in our YouTube channel, Telkom University. So, ladies and gentlemen, last but not least, we would like to invite every one of you to capture this moment joining the first ICoSEIT 2022 and upload it to your social media by using the hashtag ICoSEIT 2022. Ladies and gentlemen, we're going to start the opening ceremony. Honorable Rector of Telkom University, Professor Dr. Adi Wijaya, Dean of School of Computing, Telkom University, Dr. Zeki Abdurrahman Baizal, SSI, MCom, Chair of IEEE Indonesia Section, Dr. Ing Wahyudi Hasbi, SSI, MCom, and the representatives, General Chair of ICoSEIT 2022, Mr. Nungki Selviandro, PhD. And it's also an honor for us to inform you that among us here today, we also have our distinguished keynote speakers, Professor Zainal A. Hasibuan, PhD, from Universitas Dian Nuswantoro and Chair of Apticom, Dr. Richard Hawkins from Department of Computer Science, University of York, United Kingdom, Dr. Arya Adriansha as a Senior Enterprise Architect at Adobe Netherlands, Dr. Bassem Suleiman from School of Computer Science from the University of Sydney, Australia. And of course, our inspiring tutorial speakers, Ms. Angela Sophia Giebert, PhD from EMEA and APAC Salinist, Germany, Mr. Adam Danmanto from ID Cloud Host, Mr. Andi Sulesikin and Mr. Bahrul Ilmi Nasution from Jakarta Smart City. And of course, distinguished guests, presenters, and attendees from all over the world. Good morning. Assalamualaikum warahmatullahi wabarakatuh. Wilujeng Sumping. Ladies and gentlemen, welcome back to the opening ceremony of the first International Conference on Software Engineering and Information Technology, ICoSEIT 2022. Yayan Hamidah is here and will serve as the master of ceremony for today's great event. Ladies and gentlemen, the International Conference on Software Engineering and Information Technology is an annual event presented to you as a place to share your research collaboration for global problems, specifically on software engineering and information technology. And this event is organized by Telkom University and sponsored by IEEE Indonesia Section, and of course with our patrons, Yayasan Pendidikan Telkom and ID Cloud Host. And this is a golden moment for every one of us to open a wider opportunity to create collaboration among researchers, scientists, industry, and government sectors. Together, we are creating a new history in the first International Conference on Software Engineering and Information Technology, ICoSEIT 2022. To welcome every one of you in this opening, where I would like to deliver an opening speech by General Chair of ICoSEIT 2022, Mr. Nungki Selviandro, PhD. Mr. Selviandro, PhD, please proceed.
Greetings. First, as General Chair of ICoSEIT 2020, on behalf of the entire committee and program, would like to thank you profusely for your trust and participation in the first conference on Software Engineering and Information Technology 2020 on 22nd and 23rd November of 2020. The International Conference on Software Engineering and Information Technology, or ICoSEIT, is an annual international event organized by Telkom University. ICoSEIT is designed as a scientific activity to gather world-class researchers and scientists to share their cutting-edge research work to solve problems related to the fields of software engineering and information technology. The spirit of ICoSEIT is also to encourage collaboration between researchers, scientists, industries, and the government sector by providing international scientific events to discuss and collaborate to solve problems of interest. This year is the first year of the ICoSEIT is held. It is hoped that from the spirit that is built, it can make a major contribution to the world of research in the field of information technology at an international standard. Papers from ICoSEIT will be submitted to IEEE and Explore and Scopus. The main event of the first ICoSEIT 2020 consisted of 4 keynotes from the University of York, Dian Duswantoro University and Telkom, Adobe Netherlands, and the University of Sydney. The first conference will provide a good opportunity for conference participants to meet and discuss with fellow researchers in the same field of interest. A competition for the best paper award was also held. The first ICoSEIT 2020 received 220 submissions from 9 countries, namely Indonesia, Thailand, Saudi Arabia, United Kingdom, India, Australia, Jordan, Japan, and Malaysia, of which 50 papers have been accepted and 50 papers have continued registration by an acceptance rate of 23%. All paper submissions go through a rigorous, precise, thorough peer review process and do not get any intervention from any party to evaluate technical significance, novelty, and author quality. Each paper is independently reviewed by at least 3 experts in the field. This conference was held still during the COVID-19 pandemic, and we have decided to hold the first ICoSEIT 2020 as a virtual conference. The people in charge and the organizing committee have done their best and worked hard to deliver a virtual conference that is classy, valuable, full of insight, and engaging for both presenters and the audience. The full conference format combines pre-recorded and asynchronous engagement and The full conference format combines pre-recorded and asynchronous engagements and live engagement via Q&A and live video calls. The first ICoSEIT 2020, from initiation process to today's conference, was made possible thanks to hard work, dedication, and sincerity, and the efforts of colleagues, friends, and organizations. We would like to thank all who have participated and supported our work in many ways and are willing to help us make this event possible and successful. We express our deepest gratitude to the organizing committee and members of the technical committee, as well as all Telkom University colleagues who have helped us in planning and organizing this conference. We would also like to thank all reviewers for their very hard work in reviewing papers and providing suggestions for improving papers to ensure the quality of each paper we publish. We would also like to express our sincere thanks to the keynote speakers and the tutorial speakers. We would also like to thank all sponsoring organizations for providing their generous financial support. And finally, we would like to express our appreciation to the authors who have submitted their outstanding works to this conference and all the participants who submitted their works. With a relatively small percentage of paper passing, we can guarantee the quality of the paper that is passed and hope that the inputs given by reviewers to writers whose papers have not passed can be lessons and constructive suggestions for the future. Lastly, we appreciate your virtual presence at the first ICoSEIT 2020, and we hope you enjoy all the keynote and technical sessions and inspire your future research. We are happy to see you participate in the virtual conference. Thank you.
Well, thank you, Mr. Salviandro, PhD, for the amazing welcoming speech. Ladies and gentlemen, it's the time for us to lend our ears and open our heart for the amazing opening speech delivered by Rector of Telkom University, Professor Dr. Adi Wijaya, who will also officially commence this first ICoSEIT 2022. Professor Adi Wijaya, please proceed.
Honorable keynote speakers, Dr. Richard Hawkins from Department of Computer Science, the University of York, Professor Jainal Hasibuan from University Dian Nuswantoro, also my boss as a chairman of Apticom, Dr. Arya Adriansah, Senior Enterprise Architect and at Adobe Netherlands, Dr. Basem Sulaiman, School of Computer Science, the University of Sydney. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, ladies and gentlemen. First of all, let us praise and gratitude the Almighty God, Allah Subhanahu wa Ta'ala, because of His blessing, we can attend this event in a good and healthy condition. I am pleased to extend a warm welcome to you at the International Conference on Software Engineering and Information Technology, ICoSEIT 2022. I appreciate all of the presenters and delegates for coming and contributing their ideas, knowledge, and energy in this event. International Conference on Software Engineering and Information Technology is an international event that organized by Telkom University. ICoSEIT is designed as scientific activity to gather world-class researchers and scientists to share their state-of-the-art research work to solve problems related to software engineering and information technologies area. The spirit of ICoSEIT is also to encourage collaboration among researchers, scientists, industry, and government sectors by providing an international scale scientific event to discuss and collaborate to solve problems of interest. Hopefully, this conference can give a significant impact on the near and long-term modern research development, can be beneficial not only for Telkom University and Indonesia, but also for the world. You are a very important part of this conference success. Thank you all for your vision and participation. With saying Bismillahirrahmanirrahim, the International Conference on Software Engineering and Information Technology 2022 is officially opened. Please enjoy the conference. Stay safe and keep healthy. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Adi Wijaya, for the opening speech and, of course, the official commencement. So, ladies and gentlemen, on behalf of the committee, we would like to say welcome. Let's enjoy the event, contribute, and collaborate for global development. So the next agenda is a photo session, and we would like to invite those respected guests to be on the camera and join us for this photo session. We would like to invite Dean of School of Computing, Telkom University, Dr. K. Abdurrahman Baizal, SSI MCom, to activate the camera and join us here in the photo session. And we also would like to invite General Chair of ICoSEIT 2022, Mr. Nunungki Selviandro, PhD. And we would like to invite our keynote speaker today, Professor Zainal E. Hasibuan, PhD from Universitas Dian Nuswantoro and Chair of Apticom. Well, the three gentlemen here is already with us, so we would like to capture within 1, 2, 3. Would you please kindly give your sweet smile to the camera, sir? 1, 2, 3. All right, so thank you to the operator, but all right, so thank you so much, gentlemen, for joining us in the photo session. And the second photo session, we would like to invite every one of you guys, the attendees and the participants, to activate the camera as we're going to capture this great moment. Okay, so we have 3 slides. We're going to capture 1, 2, 3. Okay, so 1, 2, 3. That was very amazing. And for the second slide, is going to be captured by the organizer as well. You can say cheese for those participants on this slide, or maybe you can show your thumbs up to the camera as well. 1, 2, 3. All right, so the third slides, we're going to capture this. Please give your sweet smile. It's like your loved one in front of your camera. Okay, so 1, 2, 3. Wow, that's amazing. So for all the rest of the participants who will join us soonly here, we also will capture the moments along the way. So ladies and gentlemen, once again, thank you for the amazing photo session. And now we would like to move on to the next agenda. But before starting the function, please allow me to deliver a very inspiring quotation stated by Stephen Hawking, the world well-known scientist who stated the importance of learning. He once said that nothing is better than reading and gaining more and more knowledge. So we believe we're on the same page, so we're staying here to learn from prominent speakers and collaborate more for the global development. So this session is going to be presented by Professor Zainal E. Hasibuan, PhD from Universitas Dian Nuswantoro and Chair of Apticom. Professor Zainal E. Hasibuan, PhD, will be talking about integrating feature selection for alignment of supply chain and customer relationship management development. And this session will be led by a very interactive moderator, Mr. Rio Guntur Utomo, STMT, PhD from Telkom University. And please allow me to read a brief summary of our moderator. Mr. Rio Guntur Utomo, STMT, PhD, is currently a lecturer at Telkom University. He obtained his PhD degree in computer science from the University of Southampton, United Kingdom, as a part of Cyber Physical Systems Research Group at that time. And his research fields are information assurance, information security, e-government, smart cities, and e-learning. Wow! So ladies and gentlemen, let's welcome Mr. Utomo, PhD. Hello, good morning, Mr. Utomo, PhD.
Good morning.
All right, so thank you so much for spending your time, and we would like to hand over the session to you. Please proceed.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. I'm Rio, the moderator for today's first keynote session. I'm very pleased to see you here and welcome all of you to the first keynote session. Okay, the first keynote session topic is integrating feature selection for alignment of supply chain and customer relationship management development. Okay, ladies and gentlemen, our first keynote speaker today is Professor Zainal Hasibuan, PhD. Professor Zainal Hasibuan was born in Pekanbaru, Indonesia. He received bachelor degree in statistics from Bogor Institute of Agriculture, Indonesia, Also, he obtained Master and PhD in Information Science from Indiana University. Currently, he is a professor at Universitas Dianuswantoro, and he is also the chairman of Apticom. His research interests include e-learning, digital library, information retrieval, information system, and software engineering. Okay, before the first keynote session begins, let me inform how the session will be going on. First, Professor Zainal Hasibuan will be invited to give his speech, and after that, there will be a question and answer session. Okay, ladies and gentlemen, now allow me to welcome the speaker, Professor Zainal Hasibuan, to deliver his speech. Professor Zainal Hasibuan, the screen is yours. Thank you.
Okay, thank you, moderator. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. A very good morning to all participants, especially the keynote speakers and also the rector of Telkom University and all the my colleagues in Telkom University that participate in this morning. Allow me to share my presentation. Okay, let's see. There we go. Think I will. Okay, hold on a second. Let me. Okay. I hope that everyone can see it. Can you see, Mr. Moderator?
Yes, it's clear.
Okay.
Professor.
Thank you. It takes a while to retrieve it. So the titles of my presentation this morning is Integrating Feature Selection for Alignment of Supply Chains and Customer Relationship Management Development. So the idea behind this study is so far, supply chain management and customer relationship management develop almost separately. But when we look at the nature of these two areas of application, actually they are connecting. Start from the beginning where the supplies of the product or the things that need to produce some things, and then to the end, which is the customer who consumes the product. So in this study, we would like to extract or to select the features in order to develop as automation systems based on artificial intelligence, blockchains, and Internet of Things. That we develop the system in the area of red onion ecosystem. So this is the agenda of my presentation. First of all, research problems and motivations. And secondly, understanding the meaning of feature selections and methodology, because I would like to bring everyone attention where the definitions varies from one to another. So we would like to formulate the feature selection definition for this study and the methodology that we propose. And thirdly, feature selection itself, how to mechanize, to extract it, and to select it before we extract it using automation system in supply chain management and customer relationship management alignment from multi-source of data. So this is something that relatively new in the study, where the data come up from several sources of data. So it will constitute later on what we call big data. And then in order to collect and analyze the data, we empower Internet of Things, blockchain, and artificial intelligence, especially machine learning, to collect and to analyze, and also actually to classify, to predict, and to prescribe all the features selected in the dataset in order to get insight later on. And then the topic goes on, collecting and analyzing the feature selected data sets from multi-source data. This is also not only we collect the data automatically from the technology, but we also collect data qualitatively through survey, interview, observations, and other sorts of data. And from there, we develop what we call early development of value chain automation system in the area of red onion based on feature selected dataset. So those are more or less the scope of my presentation this morning. Research problems, motivations, and objectives of this study. First of all, we realized that red onion, sometimes people call it shallot, red onion is one of the strategic agriculture commodity in Indonesia that can grow almost any time. So there is no limitation at all to grow this red onion. But the problem is we face frequently, even constantly, the red onion distribution pattern does not yet describe an effective supply and demand patterns. Sometimes the situations is oversupply, makes the price drop. It means the farmer or the producers will suffer, or sometimes it is undersupply that makes the commodity, the price of the commodity very, very high, and the consumer will be suffer. So we don't want that to be happen again. So in this study, we try to find the model, the appropriate model, the supply and the consumers' behaviors that fall into the category of application of supply chain management and customer relationship management. So not only the red onion commodity itself as our focus, we also touch the issue how the distribution patterns of red onion that have a side effect like a waste, such as leaves, skins, root, that can be recycled, reused, and even reduced in order to make a more cleaner agriculture system. So this also will fall into our study. And then the objective of this study is to develop value chain models from supply chain management to customer relationship management that we look at into one integrated system. We call it automation system of red onion commodity by utilizing Internet of Things, blockchains, and artificial intelligence. Another objective of this study is to establish a robust red onion ecosystem by adopting automation system based on IoT, blockchains, and artificial intelligence. So these are research problems, motivation, and objective of our studies. So let us have a focus on what we mean by feature selection in this case. Feature selection, when we go to the software engineering, it is a feature that do something or represent a functionality. But in another definition, when we go to the data science, feature it's been just a simple attribute. So actually, behind all these two different definitions, it convey the same meaning. It's convey actually the same purpose, which is features. It is that we need to develop a system so that features can come from everywhere. In this case, we call it big data, not only from what has been defined before, but it also come from other sources of data. Actually, like data that well structures, data that semi-structures, and also data that unstructured. So that's kinds of data or that type of data more feasible right now to compute due to the availability of supercomputers, and also with very sophisticated tools that are already widely used in computational engineering. So the methodology that we use to develop that automation system and this red onion ecosystem, we call it end-to-end life cycle automation system development methodology. This methodology consists of 5 steps. First is how do we capture all data related to the production system of red onion using image, drone, IoT, satellites, and also beside that, we also touch on the human issues. We interview, we survey, and we observe the field. Later on, we choose 7 regencies in Central Java as our base of developing the model. And second step is we design the red onion automation system based on those data collected from several sources of data. And this design still what we call it microservices. It's like a module. We have several modules before we integrate it. So the integration come in the third steps, what we call it data set integration, not only from the technology 5.0, but also from other application, but also from direct connection to the objects or nodes that involved in this red onion ecosystem. And then the fourth step, we compute all the big data, all big data sets that consists of several types of data. It is very complex. We spend a lot of times in pre-processing the data in order to personalize whatever whoever involved in this ecosystem, especially the farmer. So the issues behind this, one farmer from one regencies not necessarily exactly the same with another farmer of red onion from another regencies or area. This difference is due to the height of the areas and the microclimates of the area, and also the fertility of the farm they have, etc., etc. So it is very surprised that we can cluster this farmer, and then by having so, later on, we know exactly what kind of intervention need to be introduced to those types of farmer. Before, the practice is one size fits all, one policy fits all. So through these studies, we prove that one cluster of farmers from one another area is not necessarily exactly the same with another farmers from another area or regency. Not only the farmers, but the behavior of the middlemen, of the distribution channels, and distributor itself, and also the retails, and also the consumer are very much also different. And then there's step 5, we implement the smart business automation system for red onion. So when we have this system later on, we believe that it can be duplicated or can be replicated to another commodity, such as like for example, we had tomatoes, we had other kinds of agriculture's product. Okay, let's see. So this is the design. This is the multi-source of data that we collect. As you can see here, we collect the data from climate, BMKG, Biro Pusat Statistik, OPD, that is dinas-dinas in all the regencies, and all the data, we call it structures data because it's already well structured. And secondly, we also collect data from the field directly through survey, interview, and also observation. And thirdly, from all kinds of digital sources like social media, online news, and also whatever posting that we can crawl, all together, we put it in a very nicely data set. Of course, a lot of work to do that, especially converting the qualitative data into category data, and also computing those kind of category data using one hot encoding. So, but the all works very worth it, because we can come up with a very surprisingly result. Later on, I will show you. But before that, we show you how we empower the technology in the field. So this is collecting primary data directly to the field. Like here in the example, as you can see, we have IoT that we planted in the area of the farming, and the area of the farming, surprisingly also, some of them very large and some of them small enough, but we are not neglecting any kinds of data that can contribute to our study. And then the data from IoT, send it to blockchains. Of course, blockchains guarantees that the data is reliable, consistent, and secure. So all parties that involved in the ecosystem aware the presence of the data, especially when it is harvesting time, where we don't know how much exactly the product of red onion from one area to another area. So it will impact the price of the red onion in the consumer side or in the markets. So with the blockchains, those kind of data share directly to all kinds of nodes that involves or all kinds of parties that involve in the ecosystem. And not only that, the data in the back-end office, we compute, we analyze using this artificial intelligence, especially using machine learning to capture their behavior, to capture from the clustering to the classification, and then using the classification to predict. And then from the prediction, we come up with the prescription, what kind of intervention that need to be applied to certain area. One intervention not necessarily the same with another intervention in another area. So this is what we call personalization. Okay, and then from there, as we can see, this is the way we capture microdata in the field. As we can see in the middle of the red onion farming, we put our IoT. Hopefully, the IoT stay there. No one steal it, or no one destroy it. Thanks God, until now it's there, and it keeps sending us data, all kinds of data, moisturing, climate, fertilizer, and pests and disease of plants, etc., etc. So all kinds of micro data can be captured using several sensors that we implant in that IoT system. So not only the IoT, we also endorse or enforce our data using this drone. The drone will give us suggestion whether the data or the land or the farm need to be moistured or need to be watered because maybe it's already dry, or through the colors of the red onion, it suggests whether it needs more fertilizer, etc., etc. So the data add up to all this big data set that we have. Okay, now once we capture all data from the Internet of Things, the hyperledgers of blockchains collect them and start to classify whether it's data from supply side or from the consumer side of the red onion commodity. So here we integrate all the data that possible we capture using this technology. Then later on, the data can be also integrated with the survey, interviews, and other. So in this study, as we can see, we sort of like combining the presence of technology and as well as the presence of humans, because technology will be nothing if the humans not can be explored or can be studied in detail. And also, we believe that especially the farmer and all the parties involved in the ecosystem need this kind of technology in order to improve their efficiency and effectiveness and effectivity in this value chains of red onion, start from the producers to the consumers. Okay, this is the result of our survey. The respondents consist of farmer, small medium enterprise that involve in the value chains of red onion from the producer to the consumer, and then we form the data set from the survey, and also we include data from the secondary data from the report, whether it is the report specifically about red onion or whether it's report about agriculture product, horticulture product, etc., etc. So again, a lot of works take place in collecting the data and cleansing the data, and then not only the survey, we notice several issues that interesting to be explored more detail, need to be explored more detail. So we go to interview, we interview the farmers, the actors in a small medium enterprise, the government officer, etc., etc. So all this data also we compute using the text mining. As you can see here, from the text mining, we can we can formulate the ontology. It's like a relationship from one issue to another issue. In the relational database, we call it relationship. Here we define it as an ontology. So all those together become valuable data when integrated also data from the climates, which is the BMKG, local government, and also the Google Earth, the change of the land cover from time to time. As you can see here, we have data from BMKG and also the price of the red onion from several markets to see the fluctuation of the products. We saw some anomalies, like when the products were high, the volume is high, the price is down, but sometimes the product is high, the price also is up. So very, very difficult to understand unless we support with all this data. So again, it's strengthening the motivation of our study. Okay, not only we collect the data, we also gather information from the expert through the what we call focus group discussions. The expert from the UMKM, the expert from the climate change, the experts from the government, etc., etc., and to interact with them, to explore more what their response to what happened in the field. Like, for example, when oversupply, why the price sometimes is down, sometimes is up, or when undersupply, why the price sometimes is down, sometimes is up. But why is one area it is oversupply, but in another area is undersupply? We are still in the one country, etc., etc. And more intriguing issues is why we have to import the commodity. Well, we can grow it almost any time in our country. We still have a lot of lands open. We have a very good climate that lend itself to grow the red onion, etc., etc. So from there, from all sorts of data or multi-source of data that I mentioned before, whether it is from the technology, directly from the technology, IoT, blockchains, and artificial intelligence, and also from the survey, observations, and interview, and also the secondary data from BMKG, Bureau, Statistic, etc. We put it together, and that we use it as our starting point to develop what we call value chain automation system of red onion based on feature selected data set. Now, feature selected data set, it is derived from all the features, all the attributes that we collect from the technology, from the field, and from the secondary data. Not all the features or attributes contribute directly to what we need, but surprisingly, when we compute it using like principal component analysis and other kind of cluster analysis, one attribute or one feature to another attribute, to a certain extent, they are correlated, whether it is positive correlation, weak correlation, or even negative correlation. That all contribute to the forming of clusters that will be naming later on, become classification as a basis for us to make a prediction and prescription. So this is the early result. This is the early results of our automation system in red onion ecosystem. As we can see here, so surprisingly, before we don't know, when we look at glance, the farmers just said farmer. They come from the same farmer, red onion farmer. But when you look at more details about where they live, what kind of fertilizer they use, when they start to plant, what kind of treatment they use for the pest and disease management, etc., etc. As we can see in the multi-dimension, you will see this cluster. But when we reflected to the two dimension, as you can see here, there are two peaks. So this suggests those farmers come from at least two kinds of cluster. So what it means is one group of farmers in here not necessarily exactly the same with another group of farmers here. So you can imagine if you make just one policy to the farmer, but actually they are different in nature. So of course that policy will not effective. So this is the finding, the significant finding in our studies. Okay, and then we go on from the clusterization, not only in one regencies or kabupaten, among the regencies also there are the differences. As you can see here, even though it's not that significant because the data is still growing, the distribution is not really smooth. As you can see, there are peaks somewhere. So this peak represent a specific cluster of farmer, a specific cluster of actor in small medium enterprise, etc., etc., that need specific attention as well. Of course, there are others that are can be applied to all, but at the same token, there are things that need to be specific, applied to a specific group of farmer, group of small medium enterprise, group of consumer, etc. All the parties involved in the ecosystem. Okay, and then this kinds of prescription that we produce to respond to the uniqueness of each cluster. And then this uniqueness of the cluster, we look back why it's happened. For example, there are areas that the speeds of wind may be different from another, so it'll impact the volumes of the production, and climates of the area. In the mountainous area, it's more cooler as compared to the nearby the beach, for example. So that's also give an impact to the red onion production. So we can look at more detail in that, and then from there we define what kind of intervention need to be done. Those kind of information collected together in our dashboard, and in this dashboard provide us what we call personalization. Actually, this personalization represents a group of, for example, group of farmer, group of small medium enterprise, group of consumer, etc. So by having data about each group, we can automate to a certain extent what kind of intervention need to be done. Start from, for example, supervising the farmer, providing the appropriate fertilizers, suggesting a good time to plant, and also guides them how to harvest the product, so a lot of waste can be reduced, etc., etc. So it'll give us in this dashboard, what we call dashboard of personalization. As you can see here, a lot of dashboard that you can just click, and then in almost real time, and then we can respond as quickly as possible to the need of each group that involved in that ecosystem. So in conclusion, several data collection can be automated using technology 4.0, Internet of Things, blockchains, artificial intelligence, rather than conducted by human. So you can imagine if we collect the data about climate change, about the fertilizer, about the time when they plant, who collect their product, and then where they distribute the product, who buy in the several stages of the market, small distributor, bigger distributor, and then from there, where the consumer come from, whether they are from the family that use red onion for daily life, or they are also small medium enterprise like producing a gift, dry gift for the tourists, for example. They use onion, one of the ingredient of their product, and also directly that what you call that, use the red onion to make a fried onion, etc., etc. So a lot of parties involved in that ecosystem, and it's almost impossible to collect a data as complete as possible without intervention of this technology. So that's one contribution that we think is very significant. Of course, we will not burden the farmer with this technology. That's also something probably the government or to other traders contribute to provide this technology, so that from the supply to the demand can meet in the optimal way. So secondly, the data collection come from several data. The data collection come from several data sources. So this also guarantees that all the parties involved in the ecosystems considerably play a certain role that contribute to the red onion value chain. So this is what we call big data, constitute big data. So this big data also growing. It will be useful for future research from different discipline. So that's also later on, will be our proud to have a big data set that we collect directly, not only from the field through the technology, but also from the survey, observation, etc. So there's big data not only for these studies, that also can be used for another studies from other discipline like economy, agriculture, even from the humanitarian study, social study, something like that. Okay, and thirdly, early computations and analysis from data set that come from several data sources indicate inherent structure, such as cluster axis. Cluster suggests naming that represent the cluster, and the naming we use later on as a classification. Classification we use a basis of our prediction and prescription. A lot of computation actually take place behind this, but with the limitation of this conference, I did not show the computations, but I can tell you several computation that we apply to this study. Start from the beginning when we collecting the data. We do a lot of data pre-processing, whether it is missing value, balancing the data, normalizing the data, categorizing the data, etc. A lot of work need to be done there. Once the data finish with the pre-process, it's become a clean big data set, and that clean big data set still consists of a lot of attributes, or I can say that a lot of features. Maybe not all the features have the same contributions. We look at the linear combinations of the features through several computations such as principal component analysis, and then we reduce the dimension without eliminating any kinds of early or original variable or original features or original attributes. So this is what we call linear combination. And then from these reduced dimensions of big data sets, we use it as a basis to extract the feature to design our system. So we come up the design of the system that fulfill the needs not only from the supply side, but also from the consumer side, and also the third party is the policy side, the government, etc. So that's exactly the third point that we use here. I hide the heavy computation behind it, but from the early studies, we already get indication that our computation show clusters also guarantees the different uniqueness each cluster, and that also need a unique treatment or intervention to each cluster. And this inherent structure can be used to cluster and classify all objects in red onion, all objects, farmer, small medium enterprise, government officers, consumer, and more to it, because the small medium enterprise also include small medium enterprise that directly related to red onion, and also indirectly related to red onion, such as fertilizers, distributors. Okay, and lastly, furthermore, the result of cluster and classification are used to develop red onion machine learning. We make a lot of experiment here. We choose which one that become the data sets and training set. We'll look at the learning curve. So early result, it shows the tendencies the system can learn, and so it gives us a promise that the automation systems based on this artificial intelligence, IoT, and blockchains for the red onion ecosystem can be developed. So that's all my presentation. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much, Professor Zainal Hasibuan, for giving us such an informative and interesting speech. Okay, ladies and gentlemen, now come to the question and answer session. I would like to have 3 questions from the participant, please. If you have any question, you can type in the question in the chat box, or you can raise your hand and deliver the question directly to our keynote speaker. Is there anyone want to ask question? Okay, while waiting from the participants, maybe I have one question for Professor Zainal. From your presentation, there are so many data that's collected for the research. I want to ask, what's the main obstacle, like for gathering the data using the IoT, the satellite, and also using the drone? I'm sure there will be obstacle or challenge for gathering the data. What's the main obstacle, and how can you handle the problem? Thank you. Hello,
Are you
Professor
asking me
Zainal?
the question, Rio, or I'm sorry, I
Yes.
missed it?
Can you hear me?
Okay, okay, I can hear you now.
Okay. Sorry. I will repeat the question. From your presentation, there are many data that being collected, like from drone, IoT, and also from the satellite. And my question is, what's the main obstacle or challenge when you gathering the data? Because there are so many data that's being collected, and maybe there are some problems. And how do you handle the problems like that? Thank you.
Okay, the main obstacles in collecting data is the data gatherer, yeah, or what we call data engineer. The profession now, we call it data engineer. I have to work very hard to train them that collecting data must use instrument that has been validated or something like that. Okay, not only just go to the field and then, oh, okay, oh, this is the onion field, this is the farmer, not like that. The data collected from the technology is not that difficult because the technology work by itself when it is set up, when it is installed. Okay, but as I mentioned before in my presentation, the data from the technology per se is not enough to get the whole pictures with the whole system, because our issue behind this study is to see the issue of red onion as holistic as possible, from the supply side to the consumer side. So not only technology involved in there, luckily, thanks to God, with the
Okay. Ladies and gentlemen, there's some technical problem with Professor Zainal Hasibuan. Maybe we will wait to Professor to connecting back and joining us again. Please stay in the room while we waiting Professor Zainal to be back with us again.
Also, ladies and gentlemen, we think that the speaker is currently on the internet connection problem, and to wait for Professor to be here return back to the main session, we're going to invite Mr. Rio at first to have the discussion. Maybe Mr. Rio, would you please kindly on the camera back again here? Maybe we're going to also while waiting for the speaker to join us here, we also would like to gather some questions from all of the attendees here in case you would like to ask about what he has been presented in the previous session.
Okay, so in the previous session, we had Professor Hazainal Hasibuan presenting about his research on red onion farming using IoT, blockchain, and satellite, and also drone. I think it's interesting research because usually when we talk about commodities, we usually don't use such technologies like drone, IoT, and also satellite. And what I got from the presentation is even though they use many technologies, I think it's not enough from the point of view, because Professor Zainal Hasibuan said that technology must be accompanied by data from the farmers. But there's a problem. What I got, the instrument to gather data from the farmer is hard to be validated because the data engineer itself it's not well trained enough, so it's effort to train them, and also it's hard to validate the data by the farmer itself. Oh, I think Professor has been back with us again. Maybe we will
So
wait a little bit more.
Again.
And the complete answer from my question, maybe we will see what the professor will say. The last. Okay, I think Professor is already back with us again. Hello, Professor.
Hello. Sorry, it's a blacked out. That's the problem.
Okay. It's okay, Professor.
So I'm using my handphone and also in the process of connecting through my laptop. But to continue your question before, allow me to finish it. Can you hear me?
Yes, very clear. Yeah, very clear, okay. Professor.
Yeah, so the main obstacles of our study is the humans, the human resources. So I have to train a lot of my data engineers to collect the data. If the data come from the technology, it's very much easier because it is automatically provided, but still need a lot of pre-processing activities. But the data from the human side, like observation, interview, etc., especially the data, a lot of the natures in qualitative, so we have to collect, and also the native speakers, because we go to the village, we have to use the village language, so we have to convert with the keyword they use, and then compute with text analysis, and then try to cluster and conform with the technological data, and also from another source of data, what we call it secondary data from the report of BMKG, BPS, and local government, etc. So what I would like to say is the process of data, pre-processing of data collected become data set. It is a lot of work. Once the data set's ready, it is easier to compute, because the tool, the technology is already made a scenario for the computations, analysis, for the classification. So use random form classification to see whether they're okay. So
activities in Indonesia. We have all data except.
Okay, thank you, Professor Zainal, for the answers. So what I got from the answer, from your answer, is collecting data from people is harder than from the technology. Okay, now we will wait for another question. If you have any question, please type in your question in the chat box. Okay, okay, there's one question from Mr. Novian Anggis. I'm sorry, I have problem with my speaker. So using the latest technologies to obtain, process, and distribute information in red onion farming is certainly costly. Okay, is it necessary? Oh, okay. Is it necessary to perform an initial assessment of the readiness or adoption of this technology to ensure implementation will add more value to agriculture?
Can you unmute me? I'm back now. Can me?
Yeah.
Can you unmute me?
I can hear your voice, Professor. You are unmuted. Oh yes.
No, in my other, in my. Okay. Okay. No, I'm leaving. Okay. So can you repeat the question again, Rio?
Okay, no problem, Professor. So the question is, using the latest technology to obtain, process, and distribute information in red onion farming is certainly costly. So is it necessary to perform an initial assessment of the readiness or adoption of these technologies to ensure implementation will add more value to the agriculture?
Well, okay. That's also another opportunity to explore, Mas Rio. But for sure that with only the readiness, sometimes it's not really reflect the real situations. So in our study, when we collect data from the primary data as well as the secondary data, actually with the advanced computation we apply to it, it also shows the maturity levels of each parties involved, including the farmer. So when you would like to call it the maturity level as the level of readiness to adopt the technology, etc., it can be said so. But again, the most important thing is once we recognize the behavior or the pattern. Okay, the exact word, the computational word means the patterns of all parties involved, especially the farmer. As I say before, we can intervene, action to each farmer or to each group of farmers with certain of intervention, whether it is guidance, whether it is help like fertilizers, whether it is suggestion when is the best time to plant, how to treat their plant, etc., etc. So that can be viewed as a readiness of the parties involved. So I'm not talking about adoption, like adoption of technology using technology acceptance models or UTAUTs or structured equation model, etc. I'm talking about collecting big data, and from this big data we compute to get the patterns to objects or to the parties involved, and from there actually we have whether we call it classification, whether we hold we come up with a maturity level, etc., etc. That most important thing is how to intervene them in order to optimize whatever their role, whether farmer, whether distributors, collector, buyer, or consumer, etc., etc. something like that, Mr. Rio.
Okay, thank you, Professor. So what I got from your answer is rather than using like thumb or without, the research adoption is using big data to get personalization rather than generalization. So it's like, and also it's more necessary to assess the maturity level than the readiness index. Okay, maybe, thank you, Professor Oshok. Maybe one last question from the participant. Please raise your hand. Okay, we have last question from the participant. We have Mr. Aprian Lutfan. The question is, how do you pick out the sample of farmer for your research? And are there any particular qualities they possess that must be satisfied?
Okay, this is very interesting question, Rio, because the paradigm shift that we introduce from sample data to population data, because we are using big data approach, sample data no longer relevant. But in order to do our job, of course, we cannot do it all at once. So we do it step by step. But at the back of our mind, we are not using a sampling technique at all. Okay, I underline, yeah, we are not using sampling technique at all, because our approach step by step, whatever source of data can be collected, will collect it. So the data will grow, the participants or the parties or the nodes or the objects involved in the ecosystem will grow. For example, new startup can come up with it within the ecosystem. So we are not using this any kinds of sampling technique if it is what Mr. Afrian intended to us, but we just pick, like for example, right now we start from 7 regencies in Central Java, 7 kabupaten di Jawa Tengah as our point to collect the data. And each regencies, we also pick several farmer that has large enough of land to farm in red onion, like 1 hectare above, because a lot of farmer as well have a small area of red onion farming. So, but does not mean that we are sampling it. Later on, when we finish to collect all the data, whether they have a large farming or small farmings, it doesn't matter, because the system that we develop, collecting all of them, and then try to explore what we call it hidden structures or insight within that big data set. So we don't want to neglect any one and any nodes that involved in the ecosystem. But of course, in doing research, we do it step by step. Okay.
Okay, thank you, Professor Zainal Hasibuan. Okay, maybe that's all for the question and answer session. So thank you very much, Mr. Professor Zainal Hasibuan, for answering the question from the participant. So before we close this keynote session, I would like to make a summary from this session. The first, the processing of data collection to become data set is a lot of work and problems, and collecting data from people is harder than from the technology, and the readiness cannot capture the holistic picture. So it is necessary to assess the maturity level, and rather than using thumb or without, the research adoption is using big data to get personalization. And because using big data, the sampling is not relevant anymore. So the approach is step by step in line with the data collected. And the research studies 7 farms in Java, and each farm has their own personalization. Okay, thank you very much, Professor Zainal Hasibuan. And with this, I close the first keynote session. And thank you very much for, once again, for Professor Zainal Hasibuan and also the participants. Now, please allow me to give back the screen to our MC, Mbak Yayan Hamidah, and Mbak Yayan, the screen is back to you. Thank you very much. Thank you very much, Professor Zainal Hasibuan.
Thank you, Mr. Rio. It's very good summarization. Thank you again. Thank you all.
Thank you. Thank you. Thank you.
Wow, that was a very amazing session, an interactive session led by Mr. Utomo, PhD. So thank you, Mr. Utomo, PhD, for leading this great session. And of course, thank you, Professor Hasibuan, for the insightful knowledge for all of the attendees here. And we would like to invite both of you, Mr. Utomo, PhD, and also Professor Hasibuan, to kindly join us in the photo session. All right, so Professor, we do apologize for asking you more time for having this photo session. Would like to count 1, 2, 3, so would you please kindly give the best smile to the participants? All right, so we would like to count 1, 2, and 3. Once again, is it okay if you would like to show up your thumbs to the camera? Yeah. Thumbs up to the camera as showing that it's cool moments between both of you in this great session. 1, 2, and 3. Well, thank you so much, Mr. Utomo, PhD, and also Professor Hasibuan for this great session. So, ladies and gentlemen, now we will have a 15 minutes break. You may need to enjoy your morning coffee before starting to the next amazing session. There will be the second keynote speech by Dr. Arya Adriansyah, and I believe that you won't miss the chance to grasp much knowledge from Dr. Arya Adriansyah. So, therefore, we ask you to return back for 15 minutes ahead from now on to the main room, and please enjoy your coffee break time. Honorable guests, ladies and gentlemen, welcome back to the first day of the first International Conference on Software Engineering and Information Technology ICoSEIT 2022. I'm Yen Hamida, and it's such an honor for me to still serve you as the master of ceremony for today's great event. Ladies and gentlemen, after having a 15 minutes break, we believe that you have regained your power and get ready for the next amazing session. And in this session, we're having two main agendas. Those are the second keynote speech, which will be conducted here in this main room, and the parallel session in room A, 1A, and 1B in the breakout room. So the parallel session on the track of information technology will be in the room 1A and chaired by Ms. Angelina Prima Kurniati, STMT PhD, and the parallel session on the track of software engineering will be in the room 2B and chaired by Mr. Nunki Selviandro, SCOM MCOM PhD. So for all of the presenters of the parallel sessions, you're allowed to join the breakout room now. So ladies and gentlemen, as we promised you all that you will gain valuable knowledge from the prominent speakers, so let's start the function. We're having the second keynote session presented by Dr. Arya Adriansha, a senior enterprise architect at Adobe Netherlands. Well, Dr. Arya Adriansha will be talking about enterprise-level experience architecture. And this session will be led by a very interactive and attractive moderator, the one and only Dr. Putu Hari Gunawan, SSI, MSI, MSc. So please allow me to read his brief summary. Dr. Putu Hari Gunawan, SSI, MSI, MSc, is a lecturer at Telkom University. He graduated from Mathematics Department of Udayana University 2009, and then he earned double master degree of Mathematical and Physical Science Department at Kanazawa University, Japan in 2011 and in Institut Teknologi Bandung or ITB in 2011 as well. And similarly to the doctoral program, Dr. Gunawan also earned 2 doctorates from Université Paris, France, and the ITB in 2015. During his doctoral study, a medal Le Prix Maharz Kuzenberg by the Paris, France in 2014 was obtained. Wow! Moreover, he has published many scientific papers, both in national and international scientific journals. His research focus is in the field applied mathematics, the numerical analysis, statistical learning, and parallel computing. So, without further ado, let's welcome Dr. Gunawan. Hello.
Hello, thank you.
Good morning,
Hi,
sir.
good morning.
Wow, that was very great to see you here today in this event. All right, so
Thank
Dr.
you.
Gunawan, without further ado, I hand over the session to you. Please, time yours.
Okay, thank you, MC. Today, good morning, everyone. So, welcome back to this second keynote sessions. So, introduce myself. I'm Putu Hari Gunawan. You can call me Hari, and as your moderator today in these sessions. And first, I would like to say hi to our speaker, Dr. Arya. Dr. Arya, are you okay?
Yes, thank you very much.
Okay, so Dr. Arya is a senior enterprise architect at Adobe in Netherlands. So, good morning, Dr. Arya. How are you today?
Good morning, Mas Hari. I'm doing great. Thank you very much. Really
Okay, so now you are in the Netherlands?
Yes, I am now located in the Netherlands. So it's still around like 4 o'clock.
Oh, 4 o'clock at morning. Okay, so thank you very much for coming to this conference today. So actually, I found that Dr. Arya had so many certifications in your profile. So can you maybe mention one of them that you feel very important in your career?
I think, well, all of the certifications are more or less important. I would say I'm proud to be a certified Microsoft Cloud architect. It's one of the difficult certification that I achieved, and it's also very useful in day-to-day job. So I would recommend you to get one when whoever wants to be in a professional in the cloud.
Okay. Thank you, Dr. Arya. So I think we don't have much time to talk about any. We focus on the research topic. So now, are you ready to talk to this morning, Dr. Arya?
Yes, definitely.
Okay, ladies and gentlemen, so please welcome Dr. Arya Ardiansyah to present about enterprise level experience and architecture. Okay, and Dr. Arya, screen is yours.
Thank you very much, Pak Ari. So I'm going to share my screen. Yeah, let's check. Okay, can you already see my screen?
Yes, it's clear.
Okay, thank you very much. So, Assalamualaikum warahmatullahi wabarakatuh. Good morning all, Telkom University students and all of the participants of ICoSEIT 2022. So, I would like to say first be grateful for the opportunity. Thanks for having me. So today I'm going to talk about enterprise level and experience architecture, which is a topic close to my heart. Before I start, I'd like to introduce a bit of myself. I'm Arya Adriansyah. I'm a proud Indonesian, currently living in Amersfoort, the Netherlands. It's close to Amsterdam, only half an hour drive. And currently I've been working as a senior enterprise architect at Adobe, the Netherlands, the company that also create PDFs and stuff. But before I joined the professional community, I had my stint on the academic. So having a PhD in the area of process mining from TU Eindhoven, and also published a couple of journals and citations. So I'm not really I'm familiar as well to the academics world, and I'm really proud to be a part of it as well. So this presentation is going to be divided in a couple of sections. So I'm going to start with giving you a background why customer experience is important. And then second, based on my own experience, what are the typical challenges when we conduct CX project? Then giving you some trends and how to manage the complexity in order to get a successful outcome before a closure. Now, maybe some of you still question why customer experience. So recall this person, Steve Jobs, or the head of Apple, one of the most visionary leaders that the world has ever seen. So he has this quote, and you've got to start with the customer experience and later work backwards to the technology. Because what he realized that whatever we do, whatever technology and solutions we deliver, eventually it needs to have an impact to person, to people, and then those perceptions are what matters if you want to do a long-run business. So in this presentation, I define customer experience as a customer's perceptions of their interaction with a brand. And there are several keywords here I would like to emphasize. First, it is about customer perceptions. It's not about, a definition concrete, as some we have in academia. So it is about something subjective. And this is something that customers actually define, and not us, the company or whoever create the products or the researchers. And this has to do with all of the interaction with the brand. And no, it doesn't really say where and what kind of interaction it is. So it can be interaction by, a customer going to a store, for example, and then that store gives away something. So that's one interaction with the store. But then another type of interaction could be that, the same customer hear news about the store from the social media or hear it from the radio. That's also another type of interaction. Another type of interaction could be, he has a certain conversation with his friend, his best friends, and then they mention about something unique relates to this particular store. And that's, again, yet another interactions. So this is really broad, and this is really something that is driven by customers, not really something we can properly define. And customer experience is getting more and more increasingly important, right? If you look into the trends that we see these days, where COVID accelerated the adoption of digital technologies up to manifold, as McKinsey has on their survey, this also raised the boundaries, the threshold, the expectation of customers towards the way that their brand or companies work and then give this experience towards them. So instead of now you have different expectation to different customers, brands, now many customers now start to compare their customer experience with the leading digital technologies, like the perks of Microsoft or Amazon. Although they are, not all companies can be as, as agile, as great as these big corporates, of course. But when it comes to expectation, customers now want more, right? Because they know what the technology can do. So eventually they expect the best, of course, from all of us. A study from Forrester recently shows, some relations between the customer experience, which is quantified using what they call customer index score, and the growth potential. Is something that company will get whenever they offer a certain level of customer experience. There are three patterns that we see in this particular study. First is diminishing. So with poor customer index score, then if that poor customer index getting increased by just a small amount of margin, then initially it yields really high growth. But however, as the customer rate, customer satisfaction get increased, then it reaches a certain plateau in the end. So that's diminishing, right? So do this improvement of customer experience on a poor or bad experience existing yields the highest gain. And there's also another, another type of industry for which increment on the customer experience grows linearly with the growth potential that the companies will get. So industry like auto, home insurers, health insurers, hotels. So those industries, when you give more, better experience, then you would expect also better return. However, there are this interesting type of industries that has exponential gains. So that means the company can improve their customer experience level to the customers, and at a certain point, so these minor improvements will lead to exponential growth. So that means more revenues, more customers. And that's what I think, if you look at the numbers of this exponential, it is very much staggering to see this. So take, for example, for auto manufacturers, 1.2 billion is what is expected by improving the customer index score only by 1. Right? So at a certain point, as I mentioned, there's a tipping point, and then you improve that by 1, the customer experience index. Then you get 1.2 billion estimate in average. And in another industry like management, they say the investment company, you get 22.5 billion. Also by simply increasing 1 customer index. So give better customer experience, you improve that index by 1, and then you get 22.5 billion more revenue than what you used to have before. So that's a big number in business, and hence we cannot just stay away, take it for granted that whatever customer experience we can give, it's not really important. But look at these numbers, and you probably think, hey, maybe we need to invest in this. Now, throughout my career, I've been very lucky to be involved in a couple of customer experience projects, either directly or indirectly. And here I would like to share some of the challenges. I would like to club this into 3 categories. First is the measurement challenge. scope challenge, and also in the executions. So let's start with the measurement. As I mentioned, by definition, customer experience is something subjective. So something subjective is hard to quantify. That's by per definition. What are the metrics that we often use in practice in order to measure this customer satisfaction, customer experience? Take, for example, our CSAT, NPS, customer report scores. And if you look into Forrester, they create their own way to measure this, the one that was also used in the research that I explained before, which is called CX index. However, even with all of these metrics, another study by McKinsey, also recently, shows that the existing metrics are not sufficient because people, I mean, especially the big companies, they do see that those metrics are useful, but not really complete capturing what needs to be captured from customer experience. And well, one of the reasons is that those metrics are based on survey, and just like you position yourself as a customer that gives away some information in the survey. First of all, the survey are really, subjective, right, in nature, and then it's not on top of your priority typically. If I'm a customer and I get something, a service, and I pay for it, I mean, getting a survey, hey, can you fill this in? I mean, that's not something on top of my priority. So I maybe, just do it on the fly, or I just ignore the survey at all, right? So that makes it very difficult to get a proper feedback based on a survey-based mechanism. Now, technology allows us to measure customer experience in a different way. I mean, take, for example, you have been in that flight before, right? So if you are in the airlines, and then you get into the plane, you get some consumption, some people say hi to you, the stewardess, and then they greet you, and then you get all the foods and stuff. And with the current technology, it's also possible for us to measure, right, how much time is spent from the moment you click the button to call the waiters in the air flight until that person actually come and serve you. Right? So that's one metric. I mean, the shorter the time, of course, you expect the better customer experience would be, because then you get served quickly. And then second thing, like for example, I mean, how much of the foods are left? I mean, after you get it for your lunch, for example, within the plane, and then compare it, the state of the plates after you've done. I mean, if you finish all of the foods, as somebody who maintained the air flight, you may conclude that, okay, so we deserve, I mean, we serve very good foods for our customers. However, if there are a lot of leftovers, so that can be an indication we are not serving, the food as the customers would expect us to. I mean, we need to find another type of foods that are more interesting to them. So those kind of measurements are absent, although they are actually made available by technology. We can do that quickly right now with technology say visual processing, visual computing. We know like how much of the plates are still left. So those kind of things. So my conclusion here is that it's really difficult to quantify, to measure customer experience, and there are actually like some potential to do more with technology. Another challenge on the customer experience project is about defining the scope. So consider this picture as a picture of a customer who interact with, say, different type of channels that the company has. So that same customer may access website, may access a mobile app of the same company, or get email, SMSs. First of all, I mean, the number of channels that are involved in the customer experience can be very fast, right? It's not only web that we need to take into account typically, because the same customer can also interact via other channels. They can go to, say, to the retail store, the brick and mortar, And then those experience there in the in-store channels sums up the same experience that he encountered in the website, mobile. So eventually, those are all the sum of all of this. Forms the entire experience. So you cannot really leave away just one channel in the customer experience project. Another complication is that these channels typically has dependencies. I mean, channels is only the tip of the iceberg. If you create a web application, for example, you know that it's not sufficient just to create an HTML code that runs on your browser. You do need to create some backend components to back it up, back the front end. And then you do need to connect those backend components to a system of record. You may need to analyze some of the information, connect them to an analytical layer. So soon enough, then you have different, say, depths of components that you need to take into account in a single CX project. And not to mention, to make things a bit worse, I mean, each of these layers typically has different technologies, has their own ecosystem. So when we talk about technologies that perform engagement and orchestration, then we typically have to deal with first shared experience components. So what are the components that are shared between different channels? And we need to talk about different integration technologies. There are integration via APIs, via enterprise service bus, file transfer, orchestration via business process management. And that's only one layer. So consider in a real project, how many layers you need to take into account to get a successful customer experience. And still, I mean, we are just talking about the static, the application part, but eventually data needs to flow within all of these components, right? So who's going to own that data? That's the question. And do you have the rights to actually use the data from one and another? I mean, is it in the right form, right format? Is it in the right speed? If you talk about real time, then you also expect that the downstream systems, or sorry, the upstream systems can also deliver as much as you want to have it stream on the downstream systems. And to make things even worse, I mean, these all systems typically in a big enterprise are owned by different parts of organizations. And it's not really uncommon to have, say, one application components, like for example, website, being divided into several parts owned by different parties with simply like different purpose. I mean, and what's being typical is to have separation between the open environment and the closed environment, so to say. So open environment is something that is public can access in the website. Closed environments are require you to have a certain like login, authenticate yourself. So those two are typically owned by different part of the organization. One being owned by more like a marketers and sales. That's the open environment or public communications. And the other ones are owned by, say, by products. So yeah, really like different type of organization, different people you need to engage with. So that makes really CX projects very complex. And again, I think on top of this, these days, if you recall, we have just experienced the age of the Great Resignation, where people resign from their work because of COVID, force them to think about what they want to do in the future. Is this line of work actually the one that I want to have for the rest of my life? So those kind of things. So that forces companies to also put the focus to rebuild the employee experience, because they want to retain their employee so that they can serve the customer better. So it gets more and more complicated. So talking about CX means that you're talking almost about the entire company, how they operate. And that's really one of the complexities, to define scope, which is the second part, the second issues that I often see in CX. And you do need to find the boundaries in the real CX projects. And that's a challenge. I mean, if we have some approach or academic approach to, to see this from a really objective point of view, I think that will contribute a lot to the society. The third type of say, common issue that I often foresee is the executions. And executions of this project means like you do have already a clearly defined scope. We know what to measure. I mean, what's the baseline and what are to be expected whenever we are done with this project? What are the improvement points? Making use of those measurements. Now, when it comes to executions, typically we do have an issues as well. And those issues are not only technology. Even if we talk about IT, I mean, setting up of a certain platform for experience or website, mainly we have issues in three different areas: technology, process, and also organizations. And this survey from, say, Adobe consultancy shows what has been hindering the CX growth of projects within companies. And you see, I mean, these are equally distributed between technology, process, and organization. And therefore, also in a typical successful CX project, what you see is that the support, the sponsors for these kind of engagement needs to come really high at almost at the level of CEO. So I put this, say, a survey from, not survey, an ideation from McKinsey, for which they do suggest that for all of the customer experience projects, it's better to be supported by a dedicated function that they call CCO, and that CCO reports directly to CEO. And the reason being is that there are so many things at stake here. There are so many connections to other parts of the organization that it requires really a high authority to make sure that CX project runs right. And that means also, I mean, if we are engaged in that certain project of CX and we don't get the sponsorship at this higher level, it might be the case that this is doomed to failure. And or else, I mean, we need to find, say, some other sponsors higher in the organization. Now, those are the common complexities, say, when conducting a CX project. And now I'd like to highlight a couple of global trends that impact customer experience recently. And I would like to name three among all things. So this is not by per se, I mean, a complete list. But these three are the ones that I believe like really important and I think critical to move forward. So first is about data privacy and security. Second is about distribution of data. And last but not least, artificial intelligence and machine learning. On the data privacy and security, what we see is that there are increasing, like growing concerns over data and privacy and security from the customer's point of view. So these are some of the outcome of a survey conducted by Adobe this year. So 4 out of 5 customers expressed concerns over how their data are being used. And also the other statistics supports how critical it is now for companies not only to collect as much data as possible, but also communicate to the customers. This is how we're going to use your data for. I mean, make them comfortable of sharing their own data. So recall the old issues, for example, in Cambridge Analytica, where some data are being collected, but those data are being misused. So those cases build some awareness by the customers that eventually companies can no longer collect as much data as they used to. So in order to build customer experience, in order to know who your customers are, then you do need to be careful identifying what kind of data that you need to collect it now and not later, and how you're going to communicate this with the customer so they are willing to share your data, their data. And the same, increasing attention to privacy is also shown by major vendors that produce product and that supports it. Like for example, in the web browser area, so we used to marketers used to rely upon third-party cookies to collect data to track the behavior of customers over one website and another, right? So since 2019, like, when Apple released ITP 2.1, where basically you only have 7 days expiry for client-side cookies, then it becomes increasingly difficult for companies to track, any customers end to end on all of their interaction, because within 7 days, then they need to again say either give another consent or somehow show that they are willing to be monitored, so that the same data gets pushed back to the company's backend. And these trends keep on increasing. That recently, almost all of the major browsers, and it started with say Apple, and then Firefox, and it's also followed by Safari, of course. They start by default, they block third-party cookies. So third-party cookies are popular means to track customer behavior across different websites, which is being, say, a core business of Google. I think that's also the reason why they decided to postpone it. So Google says, hey, we want to remove also third-party cookies by default, but currently they keep on postponing those moments, and at the same time we're trying to find alternative how to do the same without this third-party cookie. So that shows like a trend, and that, we are moving towards an era where it's getting increasingly difficult just to collect as much data as possible. And talking about say collecting data, regulations also now start to kicking in. In Europe, we know the GDPR, which is a rules that declares the right for a customer to be, say, informed, to be to access or rectify, erasure all of the informations, or all of the automation that has to do with decision making and profiling over their data. So it means that companies are no longer have the entire freedom just to collect data about customers and then later decide how they're going to use that data. They need to be able to explain, hey, what this data are going to be used for. And if customers ask, hey, I want to have my data removed from all of your backend systems, companies need to reply by saying, yes, we can do that, and we can prove to you that these data are deleted. So this is a very, very big challenge for companies, especially the companies with legacy systems, because the old systems are not designed to do that. I mean, we are used to think that customers' data are there for free resource, but then know that customer is gold, and when it comes to pay for this, well, some companies are just not ready. So this is one of the big challenges in the CX, because that data is the one we need in order to know profile of the customers, to give better customer experience eventually. So that's about data difficulties and the challenge and trends. But now we also look in, say, on how decentralized systems currently are. So if you recall my first part of the presentation, where typical companies, they have different business units, different departments, works in silos. So that yields decentralized IT, where say one part of business unit have their own like landscape of applications, the other one has another one. I mean, it's very aligned with the goal, the purpose, where what they are intended for. But this yields more like a decentralized IT, where each part of the company, due to the agility that they need, speed, they do need to be able to make quick decisions. And the only way to do that is to have all of their IT management, the governance, decentralized. So they can do their own local decisions, and only in some parts where it really matters, and those decisions need to be discussed at a high level between different units. So this caused a lot of issues, and one of the paradigm that emerged to solve this kind of decentralized is paradigm over data mesh. So data mesh is defined as distributed data products that are oriented around data domains. So you consider that in an enterprise, in a company, you have different business units, right? So those own business units have their own purpose. So they know what kind of data that they need in order to operate efficiently. But then some of them require data from another business unit, right? So in that case, they actually request data to a different domain. So each domain may maintain their own like metadata, vocabulary, how the data is correlated within that particular domain. But whenever that data is requested by other domain outside of the original one, so there has to be a certain governance, there has to be a certain process to facilitate, the traceability over the data, to ensure the quality, and those things are what being called like data infra as a platform. So data infra as a platform will handle everything that is required in order to transport data from one domain to another. And it's not only about technology. So the technology may be simple, but it's more about getting the right semantics in place, getting the right agreements, getting it trained, to the people that are going to use it, make them say comfortable to make use of that system. Last trend that I would like to highlight is AI and machine learning. I think there's a lot of talks about this, but what is important in an enterprise scale, it's no longer you talk about the function alone. It's all about how you manage this. So consider a situation where we use AI in order to automate some of the decisions maker, right? And that there is a bunch of developers, smart data scientists that creates this logic on how to automate those decisions. Now, in corporates, it's usual that people come and go. They resign and somebody else replacing them. So what happens in the past is that companies create those systems, and they are being applied on production. They are being used in order to automate some decisions. But then when the people left the company, the developer left the company, then nobody else can actually maintain those logic. Well, those are the logic that that do serious stuff, right? And deciding whether someone get $500 million, say mortgage or credits, it's not a small deal, of course. So as a company, as an enterprise, it's very important to manage those. So that means it's not about the creation alone, but then how to make sure that the company can maintain it, the life cycle over time, can monitor if there is something wrong, can explain whenever there is something that's happening, can protect this logic so nobody else can interfere if they don't have really the rights to do so. So it's the kind of different angle to artificial intelligence. And with this, since there's a lot of opportunities in the artificial intelligence, and if you look into some details, some of these artificial AI or machine learning relies upon models that are very much of a black box, right? So you train that model using the training data, and then you validate it, and then after validation, and then you speed it out. This is now on production. It works good enough looking at our training data model with this accuracy of performance and stuff. But then what you start to see is that, okay, it depends on how the characteristic of your training model, that models may have a certain tendency, and that can go against the ethics. And hence, we know now there is also a consensus over responsible AI, which is an umbrella terms for aspect to making appropriate business and ethical choices when adopting AI. So, and this has to do with, okay, what are the business and societal value? Is there any risk, trust, transparency on how this algorithm actually works, and not to put some people intentionally aside from another, for example. how to make it explainable, because some of these AI are by nature, they're not explained. So if you create a model, then you suddenly have this, take for example, Markov chain internally or Bayesian network. It's really difficult to explain that to common people. Hey, how come I don't get a mortgage, although I satisfy these requirements? And then you need to explain that using your Bayesian network. There's a possibility that, okay, if you do this, it's not really explainable. So AI needs to be more, how do you say, explainable when being used in order to make big decisions. That's a challenge. And it's not business challenge only, right? It's also academically, it is a challenge to create such an algorithm.
Dr. Arya, you have 5 minutes maybe for the our discussions maybe after.
Yeah. Okay. Thank you. Well, time flies. If you're having good time. Okay. I'm going to keep the last section short then in that case. So in this section, I would like to share a bit on how we manage complexity in practice, right? Given all of the challenges, all of the trends, how we as an Adobe, I mean, we deal over it and then deliver. I mean, I mean, it's, yeah, I would like to mention a little bit that Adobe has been consistently named as a leader in customer experience, and that gives us sort of like credential that we're convinced we are doing the right job here, given our reputation. So this is where enterprise architect, I see, is very critical. Because in Adobe, we pointed out enterprise architects as not only tech leads that knows the technology, but also looks beyond like data, process, and organizations. And a typical enterprise architect in our sites are, with somewhere between these definitions. So they are not really like techies in terms of the ones who are doing all of the code. They can be like, say, a bit more of a strategist, looking things at a helicopter point of view. They can be more like, say, a project manager. So it's really depends on the projects. This is, say, the roles that an enterprise architect may have. And as the first step to make sure that CX project works right, I mean, the most critical part for us is to ensure that we have the foundation over all of these, the CX. And for customer experience, what we see is that there are some foundational functionalities that within Adobe, we incorporate that as one single product. So foundational capabilities that will be leveraged or will be used by all of the applications or all of the use cases that require, say, a custom built for customer experience. So those are like identity, profiling, segmentation of audience, AI, privacy and governance destinations. So in practice, I mean, it doesn't have to be Adobe, of course, but when you look into a certain project, make sure that you identify these building blocks components. Make sure that they can be easily integrated. I mean, that's the message here. Well, with Adobe product, it's already built in, so there's nothing that you need to do more. But if you have different landscape, what we suggest is that make sure that you identify these capabilities and what are the applications it stands with it. So, and in order to manage the complexity, so recall that the typical CX project has an issue with scoping. So we adopt this way of working where we start with the business motivation always. So decide appropriately within this project time period. So what are the key business objectives, key requirements, the KPIs? Make sure that they are understandable and agreed by the business before we even jump into, the technical solutions. So this has been shown to help us a lot in, managing the scope given a certain time. And note that we also look into, user journeys, business roadmaps as a tool in order to translate all of this high-level measurement into a concrete building block that someone or developers can just deploy. And if you see here, this is one of the critical building blocks, critical tools that we have at hand as capabilities, because you do need to eventually bridge the terminology, the language of the business, with the language that we know as a developer and an IT. And so this is the capability model that we are using at a high level, really. So it defines what are the, let's say, technical foundations, privacies, and all of the other, let's say, functional building blocks that are common in the CX. So every time that we go to a client, we can easily map their requirements, their needs, their current IT landscape, basing on this particular, let's say, same language that we are reusing over the places. So that keeps the consistency, but also keep it easy for us and clients to communicate. And as mentioned, I mean, this capability model is a cornerstone. You can do it for many purposes. One purpose will be identifying the applications, identifying what are the duplicates applications that actually serve the same capability, for example, easily given a certain use case, mapping where the distribution of costs, mapping organizations, so many other things. And only based on those capabilities, then we start defining the architecture, like you see here. I mean, this is a typical architecture diagram, but the point is that before you even get into this, make sure that you deal with more like a high-level concept. And this is where enterprise architect shines, because they are the ones who are looking this like cross-arching. They may not need to be the one who are expert in defining these type of architecture, but they know who can do that and what are the relationship with other things, such as the, say, organization structure, process, also the people. So to close this presentation, so I would like to close with a note that architecting experience for enterprise is far than trivial. So it's really complex job. And hence, this architecture needs to be built by someone who has really this helicopter point of view, can talk in a different business language, and hence EA skills and practices actually becoming so much fitting into leading these kind of projects, these kind of initiatives. So be glad that we are now in a conference that also put enterprise architect as one of the topics. I'm looking forward to hear more around, say, research in this area. Hopefully, I can also make use of some of them. Thank you for your attention. So I hope that helps. I give the floor back to the MC.
Okay, thank you very much, Dr. Arya, for the interesting topics. And actually, ladies and gentlemen, I open discussion now. I invite three questions from the audience. And actually, we have one questions, Dr. Arya. So it's from Mr. Adriansia from the Data Science Study Program. And he asked about, nowadays, we know there are many companies that need a good customer experience. For example, in Adobe, MySQL, GUI, and etc. So for example, after updating the application, it turned out that many users don't like the new customer experience that is being served by the news application. So actually, what step do company usually take from these problems, Dr. Arya?
No, thank you very much. So I'm trying to reflect that to the way that Adobe works as well. In our terms, every time we release a new features, new release, we always do several steps behind the scene. So it's not just about us like preparing internally how we're going to say to launch this, but also we do some beta tests. Beta test means, okay, there are some users internally within our company that also test the products, and there we get feedback on not only the functionality but also in the user experience. I mean, which buttons that actually distracting and stuff. So that's first level, and then the second level we try to involve also customers directly. So the benefit for the customers who adopt this new feature is that then they get the features like much earlier than their competitors. But also for us, it's a means to say to get really feedback from the real customers, and there we typically have a separate sandbox. I mean, dedicated to this, because you don't want to mess out with, say, really production data. So most of the times we do a proper setup to copy this. So by the time that the tests are running, so they make use of the separate sandboxes, and whatever issues that I encounter, we monitor in that sandbox heavily, but it doesn't really impact the real production units. And then only we get sufficient positive feedback, then we release the feature to production. So those are the typical means to release a product, typical cycle.
Okay, thank you, Dr. Arya, for your answer. So I hope Mr. Adriansa is okay for the answer. And I open maybe two live questions from the audience. You can ask live directly to Dr. Arya, if it is possible. So if not, I have one questions for you, Dr. Arya. So in my question is actually how to make sure that the customer gives the right customer experience. Talk to the data. Is there any, for instance, the interval of the confidence level of the customer experience will be used to analyze the, for instance, at the end to analyze the growth potential of a company? Dr. Arya?
Yeah, so let me try to say rephrase it. So I understand the question is about how would you be sure that you are sufficiently gathering the say the information from the customers to act upon it.
Yeah.
Okay. There's no easy answers. That's to be honest. So some of these are really based on, say, you calculate, okay, how many customers you have, and then you define, okay, these are the samples. So that's one approach. You basically need to know what are the typical or the characteristic of the customers. You divide them based on segments, and those segments are defined typically by a domain expert who understand, okay, we do have, as a company, we acknowledge there are 3 types of customers, or 4 types, right? And those 4 types is translated into sort of like a persona. So that for example, one persona, so it's typically a male of 25 years old, and he has a good career and so on, and then he use the tool in this way. So we define the customer journey that typically that particular persona say follows. And based on that, then we conduct some experiments. But first, we validate those personas against the real data, and then if those are validated, only then we proceed with the experiments. But yeah, there is not really an easy way to do that, and extensive how do you say customer analysis also typically not practical. So if you have millions of customers like Nike, I mean, you're not going to go into like each individual customers and then you identify the segment based on all of the 1 million observations. It's just not doable. But the execution itself, I mean, if you already define the segments and then you want to do the experiments individually per person different, so that's what the current tools can really help you. I mean, Adobe tools can do that, and that I'm not saying that it's the only one, because some other tools can also do exactly the same. Personalization, one-to-one experimentation, so you get feedback really from one individual customers. What do they actually follow? What kind of journey? And then you build a heat map on top of it to aggregate.
Okay, thank you, Dr. Arya, for your answer. So I think I need one more questions if you have any
sure,
from the audience. Please. No. Okay, so if no, so maybe I will ask maybe one more questions, Dr. Arya. So so based on you talk about the machine learnings inside of this inside this topic that you talked before. So actually, what is the important part of machine learning that you use in this area? So is that for instance, in the classifications or the predictions or anything that's that you actually general use in this customer experience?
I think when it comes to machine learning, we make use of, say, almost everything that we do. We use supervised, we use unsupervised classification, for example. We use clustering, classification. We use it to generate content as well. So there's a lot of applicability of machine learning. So we used to think that machine learning have a certain limit, right? But eventually, it's up to us. I mean, machine learning can be applied in order to assist human tasks. That's what we see. It's not there to replace it yet at this moment, but then to assist us in doing a certain task. Hey, there is this pattern. Do you agree with this conclusion? And eventually, it's human that needs to make that decision. So we don't really see that machine learning can replace entirely how human thinks, because it's really biased towards the training data. And you say the moment that we need to make that decision, typically there are some other contexts that are not embedded in that in the training modeling. But when it comes to exercising it, I mean, in my world, I mean, it's about like customer experience. We typically use machine learning in order to find, say, next best action, next best offering for our customers. Need to find like the customers with similar profile, for example. So if you say, if I shop in a store and then I know there is somebody else that has similar profile as I do, and then that person buy these items, and I want like to have recommendation that are similar to that person. I mean, those are common right now to be used as well.
Okay, again, thank you very much, Dr. Arya, for your talk and for your explanations for some questions today. So, ladies and gentlemen, let me summarize for our discussion today. So, the customer experience is very important to increase the service quality for our company, and with the growing at the end, growing with the potential company. And also, actually, Dr. Arya already shown that there are three relations between the customer index and growth potential company, like diminishing or logarithm relations, the linear relation, exponential relations. And also, Dr. Arya already talked about the difficulty in handling in data, such as for the security or privacy of data. And also for the, he talked about the ethical concerns due to the AI as a social status, risk, and fairness, and etc. So I think again, thank you, Dr. Arya, for your talk today. So I think right now is at 5 at the morning, right, at the Netherlands.
Yes, indeed.
Yeah, it's going summer or sorry, it's going to the winter right now, right?
Yes, it's going winter, and it's it's still not yet even like subuh azan.
Oh, already. Okay, so thank you again, Dr. Arya. So, ladies and gentlemen, I will give back the screen to the Ibu Yayan. Hello, Ibu Yayan.
Yes, sir. Wow, that was very amazing session. Thank you so much, Dr. Gunawan, for a very interactive leading this session. And now we would like to invite Dr. Adrian Shah as well to be on the camera, because we're going to have the photo session between both of you as we're going to capture this historical moment. All right, so we're going to count 1, 2, 3. 1, 2, 3. As the previous session, we had twice photo sessions. So would you please kindly like giving your thumbs up to the camera, or maybe you're gonna see, or maybe you're gonna show like Korean style, like oishi or something. Yeah. So you can say that. You can show that, Dr. Adrian Shah. That was very amazing. All right, so we would like to count 1, 2, 3. Wow, that's beautiful. Sarang Heo hands gesture from both of our great scientists here today. So, ladies and gentlemen, and we will have a break for an hour, and would like to encourage every one of you to kindly return to the forum at 1 p.m. as we're going to continue for the next session. There will be 2 main agendas for the next session. Those are Tutorial 1 presented by Ms. Angela Sofia Gibert, PhD from EMEA and APAC Celanese, Germany. We'll be talking about Celanese hands-on session, teaching process mining with Celanese. And we also will have the parallel sessions led by Dr. Gama Kosala and also Mr. Rio Guntur Utomo, PhD. We believe that you won't miss this chance, of course, to get more insightful knowledge from the prominent speakers. So therefore, once again, we hope you all to kindly return to the forum at 1 p.m. But before letting you into the lunchtime, please allow me to tell you this amusing reason. Do not ever say I love you, fool. It's just because to make me look full. We know these sessions are insightful, but sorry, it's the time to make our tummy full. So ladies and gentlemen, see you back again at 1 p.m. and enjoy your lunch. afternoon, ladies and gentlemen. Welcome back to the afternoon session of the first International Conference on Software Engineering and Information Technology, ICoSEIT 2022. I'm Bian Hamida, still your Master of Ceremony for today's great session. Ladies and gentlemen, as we have promised you all that you will gain more interesting topic to discuss, and this afternoon session, there are two main agendas. Those are the first tutorial session and the second parallel session. In the parallel session on the track of information technology will be in the room 2A and chaired by Dr. Gama Kosala. And the parallel session on the track of software engineering will be in the room 2B and chaired by Mr. Rio Guntur Utomo, PhD. So for all the presenters of the second parallel session, you're allowed to join the breakout room now. So, ladies and gentlemen, we believe that after having your lunch, you have regained your more power and get ready for the next amazing session. And in this main room, we're going to have the first tutorial session, which will be delivered by Ms. Angela Sofia Gibert, PhD from EMEA and APAC Salonis, Germany. Well, Ms. Angela Sofia Gibert, PhD, will be talking about Salonis hands-on session, teaching process mining with Salonis. And this session will be led by our inspiring moderator who has the almost similar name, Ms. Angelina Prima Kurniati, STMT PhD. So please allow me to read a brief summary of our moderator. Ms. Angelina Prima Kurniati, STMT PhD, is a Telkom University lecturer. She obtained her PhD from University of Leeds, United Kingdom, and her research fields are process mining and data science. So I would like to greet our moderator right now. Hello, Ms. Angelina Prima Kurniati, PhD.
Hello, Miss Yayan.
Hello, good afternoon. How are you, Miss
Yeah,
Angelina?
I'm fine, thank you, Miss
Wow, you're
Yayan.
so beautiful today, and I guess you're ready for this amazing session, right?
Yes, sure.
All right, so without further ado, no longer, we would like to present this to you. Ms. Kurniati, PhD, time's yours.
All right. Thank you, Miss Yayan, for the introduction. Honorable speakers, distinguished guests, ladies and gentlemen, good afternoon to you all. I'd like to welcome you all to the first tutorial session of the first ICoSEIT 2022. I'm Angelina, and I'm the moderator of this session. Ladies and gentlemen, we are honored today to have Angela Sofia Gebert from Germany as our speaker in this session. Please allow me to read the profile of Angela. All right. Angela Sofia Gebert is the team lead of EMEA and APAC Salonis, and her research field is in process mining. She has a lot of publication and also has been invited in many opportunities and many events regarding process mining in Salonis. Some of them are how the Salonis academic community connects universities across the globe, and then also another process mining Cinderella story from student to founder. And the third one is enabling next-gen audit professionals from the classroom to conference rooms. All right, I think without further delay, let's welcome Angela Sofia Gebert to deliver her speech. Angela, the floor is yours.
Thank you very much, and thanks a lot for the introduction as well. So I'm here from Salonis today. We at Salonis are the market leader for process mining technology. And we have an academic alliance program at Salonis, which I would like to tell you a little bit more about as part of this presentation. So the idea of my presentation is that I would just want to give you a bit of an insight into what process mining is, how process mining works, and how you as a researcher or as a teacher can connect with us and actually start teaching or researching process mining yourself. For this, I have prepared a few slides, which I will share now. All right, let me see. Okay, can you just confirm that you can see the slides in screen show mode right now?
It is still loading, I think.
Still loading. Okay, let's see. Can you see them now?
Yes, it is good in your.
Okay, perfect. So the purpose of this session is to give you a bit of a hands-on introduction into what Celonis is and how you can use it for your own teaching and research. So what do we want to cover today in this session? I want to talk about three things. First of all, I want to give you a bit of a welcome from us and from our department, so you know how to cooperate with us. And then second of all, I want to talk about teaching with us, and then about research and innovation with us. Before I get started, I would just like to see a quick show of hands. So maybe you can put your thumbs up if you have heard about process mining technology before. So maybe you can just use the reactions in Zoom and just put your thumbs up if you have heard about process mining. All right. I see two people's thumbs up, and those are the people that I already know. All right. So my assumption is that the majority has not heard about process mining. Okay. So then I will give a bit of an introduction into what process mining is and how it works as well. First of all, why am I here speaking to you today? So we at Celonis are the so-called market leader for process mining technology. Process mining is an idea that originally comes from academia. So that was invented within academia and was then carried on to industry. And we've been doing this since 2011. And for the past 6 years, we've established an academic alliance program. So that means that we at Celonis run our own program to support teaching and research around process mining. Our mission behind this is actually quite simple. First of all, our aim is to educate the EMS workforce, so that is the name of our software, of tomorrow. So we believe that the students in the classroom today are the future consultants, the future data engineers in tomorrow's world, and we want to educate them about process mining and about our software. So our job really is to educate this workforce, and a lot of the students that have been placed with us then continued to work for our Celonis partners as consultants or for our customers as data engineers, and actually started to work in this field. So really for us, a bit of the incentivization behind what we do with Celonis is to really train this workforce and to get students connected and to get them placed with customers and partners. Second of all, our mission is to drive innovation and research. So we have a couple of cooperation programs, how researchers can cooperate with us, and how to actually drive software innovation through joint research projects, how to support PhD proposals, how to enter into research grants together, and so on. So we have a whole research and innovation department within our academic alliance. And last but not least, for us, it's also about growing the community. So connecting academics with partners, with customers. So really to create this community around process mining. With our program, we've existed for the last 6 years. We have trained over 200,000 students so far. There are over 1,300 teachers and researchers that cooperate together with us. And there's over 2,000 lectures that we have supported so far. This is a very global community, which is why we also announce Celonis Academic Centers of Excellence every year. So at the start of every academic year, we announce those schools which are particularly outstanding with regard to academic research and academic teaching around process mining. You can see some of the schools for this academic year here on the right. So this is really anything from RWTH Aachen, which is the home to Will van der Aalst, who is the founder behind process mining, LSE, UCL, UNIR in Spain, SCIT in India. So really a very, very broad community of universities. All right. Now, what is process mining? Process mining, in the end, is nothing else but a combination of two academic disciplines. So process mining combines process science on the one hand side with data science. So process mining looks at all of the typical BPM problems. So all of the typical business process management problems like automation, process control, process improvement, and so on and so on. But contrary to any other BPM technologies or BPM approaches that currently exist, process mining is a data science driven approach. So process mining uses the techniques that we already know from data science to get better insights into processes. So therefore, process mining really as a discipline is at the intersection between process science and data science. And with that is its own research discipline of its own. There are huge conferences taking place covering process mining. The most well-known one is the ICPM conference. So that is the International Conference on Process Mining. If you don't know about it yet, you should check it out. It's really, really interesting. I've been there this year in Bozen, and it was really interesting to listen to all of the talks. So it's a very active research community of, I would say, roughly 400 to 500 active researchers that are just focused on this field. And it has also turned into a technology that's used within industry. So just to give you a bit of a rough understanding, over 50% of Fortune 500 companies use process mining technology nowadays. So with that, as a research classification, I also brought this nice little definition. Process mining really lies at the intersection between process science and data science, and it bridges the gap between model-based process analytics and data-centered analytics. All right. But how does process mining actually work? So what is the core behind this technology or behind this, this approach? We can start by reading out the definition first and then take a look at the graphic below to understand this a little bit more in detail. Okay, so as per the definition, process mining is a data analytics technology to reconstruct, analyze, and improve business processes based on log data from transactional IT systems. Process mining bridges the gap between model-based process analyses and data-centric analysis techniques. So what does that mean? It means we have interactions taking place in the real world. So this is people, machines, organizations interacting with each other. These interactions are usually supported through some sort of IT system or data collector. So that means we have invoices being paid, complaints being made, purchases being placed, orders being sent out, and so on and so on. These are all the kinds of business interactions that happen on a daily basis. And very often, these business interactions don't just happen anymore, but they're usually somehow controlled through IT systems. So that means in the backend, I might have an ERP or a CRM system open, which would collect the information about this process and then help me to administer the process and to, from an administrative perspective, issue the next activity in this process. But on the go, while supporting and controlling these interactions, these kinds of data collectors also store crucial information. So this information is usually saved in the form of a so-called event log. An event log essentially just gives me all of the crucial event-related information about the processes that are supported here. What exactly an event log can look like, we will talk about in a second. The important thing is I can use this event log in order to reconstruct a virtual version of what has happened. So I use this event log to reconstruct a process model. And there's usually 3 steps involved, which we can also talk about in more detail in a second. So usually the steps involved are discovery, conformance, and enhancement. And I use this to reconstruct a model. And then, of course, I can retrieve some insights from this. I probably have some analytical insights about this, and I can use this to play the structure back into the real world, so to improve the process, essentially. And then this kind of turns into an endless cycle of supporting the process in our IT system, logging the important information, retrieving a process model, improving the process, then monitoring the process again, improving it again, monitoring it again, improving it again, and so on and so on. So it really is some sort of endless cycle of constant monitoring and improvement. And the way that this technology is used by now is it can either be used as a one-off discovery, so to look at data at one point in time and see what goes wrong and then hopefully improve the process after that. Or it can also be used constantly to look at data in real time and to constantly upload and change the data. All right. Please, by the way, if you have any questions, feel free to use the chat anytime that you like, and to also just unmute yourselves if you want to know anything. One thing I'm not so sure about, Angelina, is I'm not sure if I can see the chat, but maybe if there's any questions coming up in the chat, maybe you can assist me and just let me know if there are any questions.
Okay, I will let you know when there is any chat.
Perfect. All right. So let's make this a little bit more intuitive even. So what this means, again, is we have our business processes that take place in the real world. Our data collectors are usually our typical IT systems. So this could be CRM systems, ERP systems, SCE systems, which collect this kind of information, which we get our data from, and we then use this to do our process analytics and process improvement. Now, the kind of data that I need in order to reconstruct a process is actually quite simple. It's the so-called event log information. And an event log usually just consists of 3 crucial pieces of information and then some additional information. So an event log, first of all, consists of a case ID, activity, and timestamp. This is the first 3 columns that you can see here. And with this, I can already reconstruct a process. So a case ID usually gives me who or what I'm looking at. So this could be a customer number, an order number, or an invoice number. Then I need to know what is happening with this activity. Then I need to know when this has happened, the timestamp. And then in addition to this, I might sometimes be interested in additional master data, for example, about who was the user, who was involved in this process, how high was the quantity of things that I purchased, or any kind of other data that I might find within my IT systems. So this could also be information about what was the material that was purchased, how high was the price, which was the delivery channel, and so on and so on. And with this, I can then reconstruct the process flow for every single one of these case IDs. So what I can retrieve is, first of all, I can retrieve single events. So an event in this case would be just one row within this data table. So one row means one thing is happening at one point in time to one case ID, and I have all of the master data associated to the specific event. And then obviously, if I look at all of the events that are happening to one case ID, I can aggregate them towards one trace. So the trace essentially means everything that has happened to this case ID 10,002. And obviously within my systems, I have millions of case IDs, and every single one of these case IDs has its own trace. And I can start to cluster them into variants. So all traces with the same sequence of activity, I can cluster into one variant. And this is also how I can then get to the most simple process representation, the so-called directly follows graph. And we want to take a look at this now in the software and see what a process representation or visualization like this can actually look like in its different forms. So I will just stop the screen sharing for a second and go into the software. By the way, if you are interested to join me, this is not a must, but if you want to join me while I'm presenting, we have an academic software license that you can use for your own teaching and your own research. If you're interested in joining me, then you can go to signup.celonis.com, which is the link to our software license. And there you just need to register with your university email. Also put this in the chat. And then once you register, you will receive an email. And in this email, you have to indicate your seniority level. And the seniority level should be either, I think it's researcher, professor, or student, which will get you to the academic software license. And I will just take you into my license now. So if you want to register, then you can. If you don't, then you just follow me on the screen. And by the way, what I want to do now is I want to give a quick presentation of what this looks like in the software. And then after this, I will talk about how these different tools and functionalities can be used for teaching and research. All right. So this here is our academic software license. The academic software license of Celonis essentially is a full Celonis software license. So that means that you can work with your own data in here. So there's this data tab up here where you can also upload your own data, or you can also, if you want to use this for teaching, work with ready-made demo data sets that we have imported into the software license, which you can see here. So here we have order to cash, purchase to pay, accounts payable, accounts receivable, and a pizzeria Mamma Mia example. Today, we want to take a look at the order to cash process. And maybe just a quick question to you. Who of you knows what an order to cash process is? So what kind of process are we looking at here? Any ideas? This is a bit of business knowledge, so don't worry if you don't, but this is a bit of the business background that we need to understand this. Any idea what this could be?
Someone type in the chat box. Angela, can you read it?
No, I can't. I'm not sure why not, but I can't.
So it says that it is from ordering to payment or checkout, maybe.
Yep, exactly. Okay. Yeah, so we're looking at this process from the perspective of the business. So we are the one who sells something, and someone is making an order with us, and it's about the process of receiving this order, then making sure that the goods are shipped, making sure they receive an invoice, and making sure we get paid. So for this order to cash process, what I would have is probably this order to cash process would be supported somewhere within my ERP systems. So I might have data coming from an SAP system, for example, which gives me, first of all, the event log information and additional master data. By the way, it's not quite as simple as that. So usually in your IT system, you don't just have a column that says event log, but your event log is actually scattered through all of the different source systems or through all of the different data tables that you can find within your SAP system. But After I've retrieved all of this information, so what happens on the backend is I have a script that would be directly connecting to my source system and would try to reassemble the data so that we receive an event log and additional master data. And then I can start to explore this process. So based on the event log information that I was given, I can cluster this process into single case IDs, which each have a trace. And then I can start clustering them into variants. And this is exactly what we are doing here. So we can start out by looking at the first and most frequent process variant, which looks like this. So I just press the animation button, that I receive an order. Then I would confirm the order. So that means someone wants to order something with me. Then they say, I say, yes, that's okay. You can order that. Then I generate a delivery document, which says, okay, these are the details of how we're going to ship this to you. Then the goods are being shipped. I send the invoice and I clear the invoice, and that's the end of the process. So just like this, I can already take a look at this process in the most frequent process variant. And I can also see all of the cases that are affected by this. So in this case, it's 404,000 orders that are following this most frequent process variant. So what I can also see when I take a look at the bottom right corner is that this is only one out of 495 variants of what this process looks like in reality. So what I can also do is I can take a look at the first two variants, for example. And I can already see that in the second variant, the process is a little different. So I have an extra activity called extend confirmed delivery date, which makes the process a little bit more complicated because now I have an extra activity, and very often this also means my process takes longer. So I'm not able to make the delivery promise that I made at the beginning of when the purchase was made. So it's not ideal for our process. It complicates the process, it's an extra step, and it usually also prolongs the process. And I can also, so right now, I can see the frequencies. So how frequently is this connection here happening? I might also be interested, instead of the frequency, I might be interested in the average throughput time. So I can just go here to the left-hand side and just select the throughput time instead. And then I can see how long this takes on average to go from one activity to the next. So in this process graph, what we can see is each of these little dots here is an activity. So this is also the activity that I would find within my event log. And then the arrows are connections in between. And when I take a look at this frequency view again, I can take a look at the frequencies of each of these connections so that one activity is directly followed by another one, or at the frequency of these activities. What we have here is actually the most simple representation of a process graph. So this here is also referred to as a directly follows graph, where one activity essentially directly follows another one. Now, maybe a quick question to you. What is the downside of a directly follows graph? So if you have any suggestions, put it in the chat. So what are directly follows graphs not so good at capturing? So directly follows graphs are essentially one very simple representation of a process. They're not very good at capturing concurrency or parallelisms or anywhere where the process gets more complex. And I can also see this here. The more variants I add, the more complex this process gets. And it gets quite tangled up when I take a look at all 495 variants. Yeah, then you can see it looks like this. Suddenly it's super messy. So this here is also often referred to as the spaghetti model or spaghetti monster. So this is what happens with directly follows graphs. If you add a lot of complexity through the process, they create a lot of errors because they cannot capture anything happening in parallel or anything like this. So this is why They are really great from a business perspective to get insights into my process because they are very intuitive and very easy to understand, but they also get very messy and very tangled up very quickly as soon as I have some added complexity to the process. We will take a look at how else I can look at processes like this in a second. For now, what I need to know in addition to this is I can also, in addition to this, work with my master data. So I can, for example, see how high my sales order value was in each of the months, who my customers were. So all of this data here is coming from my master data. And I can essentially, in this with this information here, I can essentially build these dashboards from scratch in order to then do some comparative process mining and, for example, compare the process for, in particular, one customer, for example. So I can use all of my master data, and the kind of master data that I find really depends on my data and really depends on my source system. But I can use this master data to then drill down the process, play detective, and do some comparative process mining to understand potential root causes of the problem, of the process. All right, so the filters that I've set, I just want to delete them again. So I don't want to filter on one specific customer right now. I just want to look at the whole process. So just like this, there's different dashboards that I can build. All of these dashboards, they're not ready-made solutions. So this is not a dashboard that is just there and that's it, but it's really something I can build from scratch from my data. All right. Now, all of this is also referred to as so-called process discovery. And process discovery essentially just means I am discovering my process the way it really is. I'm looking at all of the data that I have and at all of the master data that I can find and trying to find some first conclusions from this. So discovery is all about understanding your process. And all of this is process discovery. Now, I can also move one step further and do so-called conformance checking. So here at the bottom, I'm just going to the conformance sheet. And I can, for example, compare a to-be and as-is process. So for this, I can actually create a process model, which in this case here is a process model in BPMN notation, which would show me what this process is supposed to look like. So this process model gives me an idea of all of the different activities and the sequencing of these activities and how they are allowed to happen. How we can retrieve a process model like this, I can also show you in a second. But essentially, this BPMN model is a different form of notation and is a different form of looking at my process. It's usually better at covering complexity. And I can either model this should be process. So I can sit down with pen and paper and have some ideas about how this process should look like ideally, or I can mine this process from the data. How this works, we will look at that in a second. And what I can then do is I can compare this should be process model against my as-is spaghetti model of the process, so against the as-is directly follow graph. What happens in the background is Petri nets, but what I get from this in the end is I get the percentage of conforming cases. I get my conformance history, so how conform is my process with the should be process over time. And then I can even get an exact list of violations that keep me from being in my ideal world. So essentially, the software suggests to me which patterns are undesired, which is, for example, an extended confirmed delivery date, or canceled orders, or returned goods, or sending out the first payment reminder. And then I can even drill down on these deviations in more detail, and I can see exactly how frequently this violation has happened and how it's affecting my throughput time, and so on and so on. And I can even go further down and discover possible root causes for this violation. So what this means is I essentially just go into my software and into my IT system in the background and try to look for correlations with this particular deviation. All right. So we already learned one possible way to look at processes is directly follow graphs. It's the most simple way. Another one is those BPMN models, which I can also use for conformance checking. And I can also construct these BPMN models from scratch. So what I can do is right now here I'm in the app section. I can only view things in here, but I can also, for example, work on these things from scratch. So I can also construct these dashboards from scratch, which is what I just want to quickly show you now, how I can do that. And so I can essentially up here, when I'm in the studio, so when I can work with things in the background, I can just go to the edit button. Then I can start editing these analyses. And what I can do is, so right now I'm in edit modus, so I can essentially change anything in here. And I can also take a look at the sheets that I have here at the bottom. And for example, create a new sheet, for example, a conformance sheet. And then it asks me how I want to create my BPMN model. And here you can see I have different options. So I can either mine my BPMN model from the target process, from the data that I have, which is what I want to show you in a second. I can also upload it, or I can also draw something from scratch, or I can pull something from my process repository in case I have stored some sort of process model which I want to use. I want to show you how to mine this process model because it's actually super simple. So if I would mine this process model, essentially, I can just take a look at my process and at the directly follows graph, and I can select which of these variants I want to have in my conformance checking or not. In my BPMN model or not. So, okay, so the first process variant looks great, but the second one probably I don't want to have. The third one has the proof credit check. That's one I want to have. Let's look at the sixth one. That's returned goods. I don't want to have that. This one here has a payment reminder. I don't want to have that either. Price changes also don't look that great. Cancelled orders are also not great. Denied credit checks. Okay, I want to have that. So because I also want to be able to deny the credit check. So let's just say that our ideal process would consist of these 3 process variants. And then I can just select those 3 and launch my analysis. And just like this, I can receive my BPMN model from my event log data. So I can now see that this is what can potentially happen, so that I can potentially have an approved credit check, but not necessarily. And I can also now, for example, add more complexity to this process. So I can, for example, add new connections, new connections or new activities, for example. So I can say, I don't know, maybe canceled orders are also fine. So I will have this here. And then I can essentially also start connecting any kind of deviation and draw this from scratch. Okay. So much about this. Is there any questions about this so far? Yes, there's one from Nungi. You can unmute yourself if you want.
Okay, thank you, Angela, for the interesting presentation here. Actually, I'm a kind of newbie in this process mining, but yeah, it's a very good presentation from you. So it's kind of like I'm more interested in process mining right now. And it's just a question about the tools, because I have registered to the website that you give the information on the chat.
And how can we access the tool here? Because it looks very nice for exploring maybe.
Yeah, so if you've registered for signup.celonis.com, you can directly access the software license. So you should have received an email, which gives you, so after putting in your email, you should receive an email that says create your account. So you just have to enter your your information about your university, where you come from, and then everyone, so this is our academic software license, so every researcher or lecturer or anyone who's associated to university has the right to have access to the software license, and you can either work with your own data or work with some of the existing demo data that we put in there. But obviously most of the researchers want to upload their own data at some point.
Yeah, all right, thank you. Maybe one more question. So the thing that I got from so far from this presentation, that we can create our as is business process, let's say from the order into the checkout or payment, and we can analyze and identify, maybe create a more efficient business process with these tools. Am I correct?
You can, yeah. So first of all, you can use it for process discovery. So you can look at your as-is process and understand what it looks like. But you can also obviously use this to then, for example, construct an ideal model of the process and to compare this, for example, as you would do in conformance checking.
All right, all right. Can we also add the actor with this business process in this tool?
Say that again.
Okay, can we add the actor, the interaction with the process and the actors, maybe the stakeholders with a specific process?
Yes, and there's a tool called Social Process Intelligence, which gives you exactly that kind of information. It's a bit of an issue because sometimes, for example, for GDPR reasons or for like to protect your employees, you're not allowed to analyze data like this. But you can also, so if you're interested in who was involved in the process, you can also look at that kind of information.
All right. Perfect. Thank you very much for your answer. Maybe we can continue. Thank you.
Sure. All right. So now you've seen two ways of looking at my process data. I actually want to show you one third way, which is really state of the art and was actually just published 2 weeks ago at our Cellosphere conference. So I'm not sure who of you has heard about object-centric process mining so far, but essentially the idea is that with this, you're also able to capture parallelisms more easily, and it's really one of the more innovative ways to look into process discovery. And this is a new feature that we have launched in our software license 2 weeks ago. So it's actually not even available on the market yet. It's really super new. So it's about to be published, and we will also have it available for our academic license, probably at a later point. So it takes a little bit of time until we have it in the academic software license. But I still wanted to show it to you because it's really state of the art. And I've had a couple of academics who approached me who actually said, we never did something with Celonis before, but now we want to do something. And we're really interested in this object-centric process mining. And it's really great to see this. So I just wanted to give you a quick demo of that as well. Now, unfortunately, I don't have a demo data set for this yet, but I have a demo video that I can show you just so that you can see a third way of representing a process graph with the help of Celonis. So I just want...
Before that, there is another question from the audience. Do you mind to take it now?
Yes, sure.
It is from Pak Kemas Rahmat. Pak Kemas, can you unmute yourself and ask your question?
Oh, yeah. Thank you, Angela. Just a little bit curious about the technical aspect. I will not ask in very detail, yeah. But I just want to know how you guys built this clean and beautiful tool, especially for the graphical user interfacing. Did you use any cutting edge technologies for doing it?
I'm not sure how to take this question, because when you look at process discovery, it's really just process discovery algorithms that are behind this that would get you towards, your process graph that you want to look at. There are also, and I can show you, I can talk about that in a second later as well. There are obviously a lot of overlap topics where, for example, you would look at, how process mining interacts with other disciplines. So you would look at how process mining, for example, interacts with automation or something like this, or how it interacts with prediction. So there, what you would do, for example, and what we also do is, if you want to look at process prediction, you would look at the process in real time. So you would look at things as they come in, and then we would actually just connect to a Python script. So you can just use Python as a plugin for Celonis to then run a prediction and train an algorithm to tell you, when is the next order going to be late? Or when will we have the next change price or something like this. So prediction is definitely something that has a lot of overlap to process mining, and that is also actively researched at the moment. Another topic that is really hot and that is really overlapping quite a lot is automation. So how can you now use those insights to, for example, improve the process and automate it? But really what's happening on the process discovery side, so the core process mining thing, that's really, what's also researched right now a lot. So it's about all, those discovery algorithms, inductive mining, there's the alpha algorithm. So that's like standard core work within the field. I hope that helps to answer the question a little bit, but I'm not sure if you were aiming for something different or if that is what you wanted to know.
I think it's enough. If I have another question, I will ask Angelina, or maybe ask you that directly.
Okay. Thank you.
Yeah. I hope that helps a little bit.
Please, Angela, you can continue.
Okay, perfect.
Process sphere reveals the full...
No, stop. Okay, so I just have to go back into screen sharing. So this is just something that is really, really recent. We presented this 2 weeks ago at our huge Celosphere conference. And I just thought I'd give you a bit of a glimpse about, what else can be done for process discovery. Let me just see. So you have to give me feedback whether you can see the video and also hear the voice. So I will play the video now.
Process sphere reveals the full end-to-end map of your business, giving you a complete...
Oh, wait, can you see it in full screen already?
Not in a full screen yet, Angela.
Can you see it now?
Yes, it is now.
Yeah. Okay, let's try again.
Process sphere reveals the full end-to-end map of your business, giving you a complete understanding of how complex processes run and interact. It does this by analyzing the objects and events that make up your processes. Objects are the individual items that are processed, for example, sales orders or purchase orders. Events are the process steps that apply to those objects, like approvals, changes, or status updates. Let's dive in. In Process Sphere, the flow of each object is visualized as a subway line and is colored for easy differentiation. Here we can see the journey of a single object, the incoming customer orders, as well as the key events associated with them. In addition, for the first time, we can clearly see which events only happen exclusively, indicated by diamonds, and which events happen in parallel, indicated by horizontal bars. This makes the process significant to read and understand, allowing us to spot inefficiencies more easily. As we select multiple objects across different processes and include every flow each object could follow, we see the true complexity of how the business runs across departments and silos. This gives us a complete view of the inefficiencies hidden across the supply chain, not just within, but also between multiple processes. But the real power of Process Sphere is not just its ability to capture this complexity, it's how accurate and quickly we can get to the root cause of a business problem. Let's see how Jane, our process analyst in the Celonis Center of Excellence, uses Process Sphere. Her company SpaceNext sells eco-friendly tech to customers, but the on-time delivery for the company's most popular product, electric scooters, has recently dropped. she's been asked to investigate why. Jane starts with the order-to-cash process to analyze on-time delivery performance. She selects sales order, the key object involved in order-to-cash process. For Space Next, a typical sales order consists of an e-scooter and the batteries for the scooter. To start, Jane focuses on just the order management objects and takes a closer look at the throughput time for when orders are created to when the respective deliveries are shipped. For the first time, she can see the throughput time for events taking place for two different objects, sales orders and deliveries, and she can benefit from embedded visualizations of the data without needing to leave ProcessSphere. She immediately sees that the average throughput time is 7 days. As she filters on all the unusually long-running orders, she sees 2 million deliveries flow through the event, insufficient material found. The problem is clear. Customers aren't getting their scooters on time because there isn't enough material available to fulfill orders. The question is, which material and why? Jane wants to look upstream to understand what's happening to the incoming goods and procurement, so she adds in the relevant objects. Her view now reflects the intersection points of the procure-to-pay and order-to-cash processes. This simplified view across two independent processes was previously impossible. Jane filters on the materials that are delivered late and sees that batteries for the scooters are the main cause behind the late orders. Now that she knows what the missing materials are, she analyzes further to see why these batteries are delivered late. She sees that invoices from the battery vendors flow through the event, receive payment overdue notice, meaning the vendors are sending reminders to follow up on late payments. She verifies that the vendors are consistently paid late regardless of their delivery performance. As we saw with ProcessSphere, Jane got a full view of her business across different processes, and in just a few minutes, she was able to zero in on late payments to suppliers in the accounts payable process as the root cause of late deliveries downstream in the order management process. And now that Jane knows where the issue lies, she can engage the AP team to fix it.
All right. So this was just a bit of an outlook into, what process mining can also do nowadays. This is not yet available in the academic software license, but it will be at some point, hopefully within the next year. So if you're interested in this, then I think it's a great way to see, how different process models also have an effect on how we can see and view a process. All right. Now, what I would suggest, so we're at half of our session time. For the second half of the session, I now want to talk about, so now you've seen Celonis, you know what the Academic Alliance is, you've seen the software. And for the second half, I want to talk about how you can use this for your own teaching and research, and talk a little bit about our teaching and research offering. My suggestion would be, Angelina, so I think we're good in time, but that we just give people a 5 minutes break. And then after that, talk about teaching and research. Would that be a good idea?
Yes, I think that's okay if you need it.
Okay, perfect. Then I would suggest let's do a 5-minute break. For me, it's 8 a.m. Then I'm not sure what time it is for you, probably 2 p.m. or something like that.
5 to 2 p.m., yes.
Perfect. So then let's meet in exactly 5 minutes, and I will give you a bit of an outlook of what you can do together with us. All right, see you in 5.
Yeah, thank you, Angela.
All right, so ladies and gentlemen, we're going to have a 5 minutes break before starting to the help session with Miss Angela again. So maybe we're going to play back here with all of you guys. We also would like to remind every one of you to prepare for so many questions that you can deliver to our speaker for today. And of course, it's going to be very great for us to have a very interactive collaboration, which will be led again by Ms. Kurniati, PhD. So ladies and gentlemen, we're going to back to you again 5 minutes from now on, as we're going to start to the help session of this first tutorial session. and gentlemen, welcome back to the first tutorial session. And now we're going to continue for the hot session with Ms. Gilbert, PhD. And I'm going to hand over the session to our great moderator, Ms. Kurniati, PhD. Ms. Kurniati, time's yours.
Thank you, Ms. Yayan. Ladies and gentlemen, now we will continue our session, our tutorial session with Angela Gilbert, with more discussion about how we can use Celonis for teaching and also research. Please, Angela, the time is yours.
Perfect. So for the second half of the session, I wanted to just spend some time to explain our teaching and research program to you in a bit more detail. So for this, let me share my slides again. Okay. All right. So we want to spend the second half of the session to talk about teaching and to talk about research with Celonis. First of all, what you need to understand when you are interested in teaching and research together with us is that there's a couple of platforms that you can use free of charge. So our academic platforms, just to have a bit of an overview. First of all, we have a partner portal. You can always find the corresponding links also in the presentation, and I'm sure we can also make the presentation available to you afterwards. So the partner portal is our one-stop shop for educators. So it's essentially a portal which contains different teaching materials, exercises, but also booking forms to join our official Celonis Train the Teacher sessions, to join events, or also our certificate cohorts. So the partner portal is really designed as the one-stop shop for any educator who is interested in using process mining and who wants to access teaching materials, exercises, and all of the many things that we have constructed. Second of all, we have the Celonis Academy. So the Celonis Academy is our online training platform, and I will give you a demo of the Celonis Academy in a second. So the Academy essentially contains different training tracks and courses that you can take if you want to learn about process mining. And it also contains special academic training tracks that we have designed just for academics to take. Usually, if you want to take any of these training tracks, getting a certificate in the end is costly and also involves an exam which costs money. For our academic training tracks, we actually waived that fee, so you can take all of those training tracks free of charge and also obtain a certificate free of charge, and also use that for your teaching as a blended learning approach, for example. And then, last but not least, we also have our academic software license, which you have seen just now. So this is the environment you saw just now under signup.celonis.com, where we have demo data sets, you have all of the Celonis functionalities, and you can also upload your own data. And then if you're interested in this, we also have Make, which is a subsidiary of ours. This is a software just focused on automation. So if you are interested in automation, you can also use the academic software license for Make, where you also can build your own scenarios and have free demo scenarios that you can use. So if you're interested in automation, you're also welcome to use the academic license of Make. All right. So just to sum this up, we have a partner portal, which has all sorts of teaching materials, resources, exercises that you can use for teaching. We have the Celonis Academy, which is our training platform. And then there is 2 software licenses that you can use, and all of this is free of charge. If you now want to become an educator with us and become a certified educator with us, there's a journey and steps that you can follow. First of all, you can start by, joining our program, hearing about our program somehow. So today could already be the first step in your journey. Then we offer official Train the Teacher sessions. We offer our next cohort of Train the Teacher sessions in February. And these are sessions designed to get you up to speed about the Celonis software license and about process mining. So they are sessions designed to teach you how to teach process mining. And then you can teach your course. You can notify us that you have taught your course. So please let us know that you've done this. And after this, you can become a Celonis certified educator. So there's also an official badge that you can earn for this, and just join our active educator community and exchange with other educators and industry experts. As I mentioned before, we have academic centers of excellence, for example, but we also have a couple of other community events where we bring together our educators from across the globe. If you decide to teach your own course with process mining with Celonis, it's essentially a bit of a building block system. So you can essentially pick and choose the things that you're interested in and that you want to include in your classes. So first of all, what we always equip you with is the software access. So the technology access really goes first. So it's really to make sure that you have access to the software license and that all of your students also have access to the software license. Then, if you're interested in this, you can mix and mingle this with our other offerings that we have. So, for example, you can choose a blended learning approach and decide to let your students do some online learning on top of this. I will show you this in a second, what this looks like, but in our Celonis Academy, we have a couple of different classes that we provide, which is, for example, a 1.5-hour introduction to process mining course. We have a course, Process Mining from Theory to Execution, which is a 10-hour class together with Professor Will van der Aalst. We have a Process Mining Fundamental Certificate, which is more applied in the software, which is an advanced software training, and it's 20 hours. And we have our Process Mining for Audit Professionals training, which we developed together with Brigham Young University and Ernst & Young. So essentially what you can do is you can essentially pick and choose from the learning materials that we provide to give students an even better blended learning experience. So on top of the coming into class, they can take these trainings in addition at home, for example, in preparation for this class or after your class. Then, if you're interested in this, you're also very welcome to use any of our teaching materials and to also mix them with materials that you construct yourself. So what you can do is either you can construct your own slides or you can use the Celonis lecture slides and then, for example, combine this with any of our applied exercises in the software. So these have different lengths depending on what you want to do. So this could be, for example, just like 15 to 20 minutes, process discovery, consult the pizzeria Mamma Mia, can be 10 to 60 minutes P2P or order to cash exercises, which is multiple choice. It can be analyst exercises where students get to build these dashboards from scratch. Or you can even give them an advanced assignment throughout the whole of the semester and let them create their own case with, for example, a demo data set that we provide, and they have to build this from scratch. So essentially, it's up for you to pick and choose what you are interested in. And I would highly recommend, if you're interested in this, afterwards, you can just reach out to me, write me an email and say, yes, I want to teach about this, and schedule a consulting session to talk about your specific class, how long it is, the students' backgrounds, and see which of these materials might be fitting. All right. Now, I also want to give you a bit of an idea of what the Celonis Academy, so our online learning environment, looks like. So next, I would like to do a quick demo of that and just quickly show you what this looks like. So I just need to go into a different presentation now again. Here we go. So hopefully, yeah, you should be able to see the presentation now. So this here is our Celonis Academy. So in here, I can first of all browse our course catalog and look for all courses on all training tracks. I can also see, for example, the courses that I have recently taken. So all of the classes, all of the training tracks that I was recently involved in or that I recently completed. So for me, it's very easy to access. So it's very easy to understand where exactly here in the software license I am and what I want to see. So if I go into our course catalog, which is where you would also look for our training tracks, I can just click on training tracks up here. And then I get a suggestion of all of the different trainings that I can take. And you can see there's a lot of them. What's important to know is all of these training tracks, they're also designed to train our Celonis customers and partners. So a lot of them are not really applicable to academics because they're sales trainings or trainings about how to create value. But there's also trainings which we specifically designed for academics, like, for example, our course, Process Mining from Theory to Execution. So if I click on this course, so if I say I'm interested in integrating this course into my teaching, then I can just click on it. So now I'm here in this specific course, and I can see the different modules that this course consists of. So I can see the course comes in different chapters. There's a welcome chapter. There's an overview of the field and basic concepts, process discovery and directly follow graphs, discover sophisticated process models. So there's all of the things I can learn about. And I might just be interested to go into one of these courses within this training track. And then it takes me directly into the course. Just needs a second to load. There we go. And now we are in this course directly. And in here, I can see this course again consists of 3 chapters. The first of them is a theory lecture, then there's a Celonis hands-on section, and then there's a knowledge check area. And I can now take a look at this theory section. I can read through the reading material behind this. And then there's always little videos.
Welcome to Lecture 1 of Process Mining from Theory to Execution. I'm your instructor, Wil van der Aalst. Process mining is a complex and continually expanding field of study. From its conception as a research topic in the late 90s.
All right, and so on and so on. I can see if I scroll through this, through these lectures, I can see there's always lecture slides being blended in, and then there's Will explaining something again. So it's really supposed to be a very interactive and fun experience to learn about process mining like this. After this theory part, so this here is the theory that Will is covering and that Will is reporting on. After this, there's a Celonis hands-on session. So let's look at the hands-on session, which is someone from Celonis explaining how this theory can now be applied in the software. So let's look at the demo here.
Moving from theory in the classroom to real-world application can be a challenging transition, but it's an integral part of the learning process and one that, unfortunately, is oftentimes left up to the student to navigate. One of the main goals of this course, Process Mining from Theory to Execution.
All right, and then I can see this course continues, and as it continues, it's always a software demo.
Case, activity, timestamp, and event log. Let's start by looking at an illustration of a typical business process. We're going to look at a purchase-to-pay process in Celonis. Purchase-to-pay refers to the process of B2B purchasing, where one company buys, for example, equipment or the purchase-to-pay process looks at the whole purchasing process.
So it's always like this. So this course always consists of a lecture delivered by Wil van der Aalst and a Celonis hands-on section. And then at the end of each of these lectures, you get to check your own knowledge. So there's applied questions that you can answer, and you can test your knowledge just like this. So just like this, you can, let's do this again. So you can, for example, to really apply it in hands-on exercises to learn about this. And yeah, they're all different sorts of exercises. So this one is a sorting exercise, for example, to check your knowledge and to see how well you understood the contents that were delivered as part of the class. All right. So just like this, every one of these lectures, and there's 7 lectures altogether, consists always of theory, Celonis hands-on, and knowledge check section. This is just one of the many trainings we offer. We also offer, for example, our process mining for audit professionals training together with Ernst & Young and Brigham Young University. We have our process mining fundamentals training track. So there's really different training materials that you can use to also give your students a blended learning experience. And the nice thing is that at the end of each of these training tracks, students also receive an official certificate. We work together with Credly, which is an official accreditation institute. So students also get an official certificate that they can share on their LinkedIn profile or put on their CV. All right. Now, this is all I would have to say about teaching for now. I want to finish off by talking about how this can be used in research as well. So if you're interested, not in teaching, but more in the research aspect of things, we can also help you with that. Within our academic alliance team, we have one person who is just focused on research and innovation. So she works as a research and innovation coordinator in our team. And there's a couple of things we want to achieve with our research program. So the mission behind our academic research and innovation program is really to, first of all, democratize research. So we want to really empower researchers in any discipline to provide for a variety of research projects and research formats. Of course, obviously, we also want to generate leading insights and valuable insights from this. So for us, it's about also supporting leading research and innovation and ourselves being at the forefront of research and innovation, and to also, through our partnerships, for example, gain new insights into new ideas that we could do. For example, this very last representation of this object-centric process mining, that is an idea that is again coming from research. So this idea was actually, brought to us by Professor Will van der Aalst, who said, hey, you should have this in the software. So all of these ideas actually also come from research collaborations. And it's also about generating a global network of experts that are united in our research and innovation program and just provide expertise for process mining in the different fields of applications and from very different angles. So in our research program, right now, we have established a very strong network. There are over 760 institutions that do research together with us, over 1,250 academic partners that do research with us. And actually these numbers are outdated, I'm so sorry. But yeah, here's some of the partners that we that we collaborate with. Essentially what you can do and how we can assist your research is we support research on a variety of levels. So first of all, there's different types of projects that we support. So we support, for example, thesis projects, like PhD theses, for example. We also support student projects, capstone projects, for examples, or master's and bachelor's theses. We aim for joint publications together. And we also support hackathons or competition-like scenarios. If you want to do something like this with your students, this is also something we can support. How we support you? We support you with, on the one hand side, technology access, and on the other hand side, personal support. So from the technology perspective, for example, we have our academy classes where you can yourself learn about process mining. You've seen one of them just now. We have an advanced EMS license. If you want to use process mining for research, you can also always contact us and see if there's any special features you want. Or, for example, our normal table row limit is at 100,000 table rows for for the academic software license, if you need this to be set up, this is also something we can do for you. And we have an active community that we can provide, we can connect you with, and we also offer enablement sessions for researchers if you want to learn more about what you can do or also exchange with other researchers. And then last but not least, we also provide personal support to you. So for example, if you need a letter of intent or something like this, on a selected basis, we can also write these to support your projects. We can offer you exchange with other researchers and also with our Selonauts if you need that. We go for associated partnerships in joint research projects. And we also apply for public funding, for example, and could be a consortium partner within your research application. Obviously, all of these ideas and services are on a very selective basis. So you can imagine we get hundreds of research proposals every quarter. So it's really a lot of research proposals that we get. So obviously it depends on your specific case and on what you specifically want to do, but this is all within the portfolio of what we can do. And then it depends on your specific proposal, whether we actually want to, enter into public funding together or are able to write a letter of intent or something like this. So this then depends on the specific research proposal. Some of the projects that we have, can you still see my presentation? Yeah. Some of the projects that we have supported so far. So right now, there's around 40 academic research projects in operation right now. 55 projects have been delivered within the last 12 months. And there's around 900 thesis projects that we have supported so far. Some selective projects that are currently running would be these three here. So the first project that we are currently supporting is, for example, AI for Pro. So this is a production research project, which is focusing about how to obtain and utilize sensor data within production pipelines to essentially create an event log from this and to just essentially bring in a new data collector for production processes. This is a project we're doing together with Fraunhofer and a couple of German-based companies that are involved in this. Another one is ProVSA, which is about value stream analysis and trying to find a new EMS-based value stream analysis approach, which is a project we do together with the Technical University in Munich and Harvard Hydraulic. Or the AI adoption project, which is about customer usage behavior and how customers actually adopt and use the Celonis software license and how we can actually identify best practices for working with the Celonis software license, which is something we do together with McGill University in Montreal. So if you now think that this is interesting for you, you can also get in touch with research proposals with us. So your way to us, so this is actually Sarah, my colleague, who is who is our academic research and innovation coordinator. So you would be getting in touch with her. And the way that you can do this is, first of all, you can become familiar with who we are, what we do, and so on, and also our software license, and sign up for our academic partner portal. Then next, you can identify the topics and projects you are interested in and write a research proposal or abstract. This should cover the idea and topic you want to work on, the timeline you want to work on, and the kind of input you require from Celonis for this project. You can then hand in your proposal, or if it's a thesis project, you can also sign up for our thesis program. And this will then be evaluated by Sarah. She receives all of these project proposals, and she will evaluate whether we're able to help and support with your project. And if it's evaluated in a positive way, then you can get access to the software license. We can write a letter of intent or whatever might be applicable for the specific project. So it's really an encouragement to think about whether you want to do something with this. And if you do, then you can hand in a proposal and we can see what we can do. And I think that already brings me to the end of this session today. So I know we still have a little bit of time left. So my suggestion would be that we just now enter into a Q&A mode. And if you have any questions about our research, about our teaching program, or also about Celonis and process mining as such, then I think we can use the remaining time to answer any of your questions. And I will stop my screen sharing now again.
All right, thank you, Angela. So dear all participants, if you have any question or anything to discuss with Angela, please raise your hand and we will unmute you to deliver your question directly. While waiting, Angela, is it possible for us, because we have also undergraduate students in our university, possible for us to maybe propose to you to help us supervising our students to work with real case study and using Celonis for their final project? Is it possible for you?
Mm-hmm. So what we have is we have our Celonis thesis program, which you also saw the link for. So if you have undergraduate or graduate students that want to write a thesis, they can apply through this program. It's the same as with our other research proposals. So it also depends on whether it's evaluated positively or not. But in most cases, we are able to at least provide some reading recommendations on what they can do. And in some exclusive cases, we're also able to, for example, connect those students with people from our development team and so on if they're interested. So it's still, all of these research proposals are up for evaluation and we receive a lot of them. But most of the time, there's at least something we can do and something we can offer.
Okay. So for that case, is it possible if we have the data or if we have the connection from another institution in Indonesia, and then we want to get their support from Celonis as a supervisor, something like that? So it's not, should it also be selected by Celonis team, or can we just tell you that we already have a complete pack of students who already have the data, already have the case study, and we only need a supervision from someone in Celonis? Is it also possible to help us with that?
Yeah, so it's usually even better if you already have a concrete proposal. So getting the data is one of the most tricky things for process mining analysis, because you need to get someone's consent to put the data into the cloud, obviously, and you need to find that first. So usually I would even recommend this if you already have another company you want to work together with. The chances are usually a lot higher that this will work out.
Thank you, Angela. Pak Nungki, please. Okay, you can do it.
Okay, thank you, Miss Angelina. And if you don't mind, Angela, I'm really interested in the tooling again. So if you don't mind, if I'm asking about the tools again. So basically, the tools is helping us to visualizing our process in our business, right? So if the tool supporting the real-time data gathering or interaction with another system, maybe, or it just asks to typing the process and inputting the data and something like that. Thank you.
Yeah. So it's usually what happens for our customers and partners is we have a real-time data connector. So what you have is you have this data connector, which is just a script connecting to your source system, saying this is the data columns that we are interested in, and we really do data uploads every couple of seconds. So it's really real-time. In the academic software license, though, we work with Excel data uploads because we couldn't make everything available at once. So in the academic software license, it's a one-time data upload. But if, for example, you say you have a research project where you need a direct connector, then again, this is up for evaluation, but there are possibilities to also make features like this available if there is a concrete project plan.
All right, perfect. Thank you for your answer.
Sure. Right, and I think we have another question from Tisa. Yes, if you want to go with your question. So I'm not sure, maybe it's not a question. She cannot unmute herself.
Okay. Hello, Angela. Thank you for your marvelous explanations. And my question is there any challenging part in using Celonis beside the data itself? I mean, perhaps we must become more familiar with the features, and then what else do you think that we need to make ourselves challenging in become more famous, familiar, and so on and so forth? I think that's my question. Thank you.
Yeah. So I think from a research perspective, I think there's always two things. I think on the one hand side, it's about getting familiar with the software and understanding how the software works. So this is one thing that you need to learn essentially. And for this, we have trainings, for example, in the academy. So you know about the Celonis features and you understand the software and how it works. I think the other component is also always the academic side of things. There's excellent trainings around process mining that are available also from an academic point of view. So I think I dropped the name Will van der Aalst a few times. He is the person who invented process mining. For example, we have his course, Process Mining from Theory to Execution, but he also has a Coursera course. He has a book that he has published around process mining. So also trying to understand the academic challenges around process mining is really helpful. And process mining is one of the few disciplines where what's happening in research and what's happening on the technology side within industry is so closely interlinked. So there's innovation taking place in research, and it's directly, immediately adopted within industry. And it's just like a field where academia and industry interact so closely together with each other that it really offers a lot of chances to also do cutting-edge research, cutting-edge technology. But I think for this, it's important to understand the current challenges that are there. And I think some of these challenges are, for example, more around how can we capture parallelism? That would be more like the object-centric process mining. How can we do process enhancement? How can we run predictions? But it's the same kind of problems that are currently addressed in academia and that industry is interested in. And that offers a lot of possibility if you understand these problems and understand the key research areas that currently exist within the field.
Thank you, Ms. Tisa, for the question, and Angela for the answer. Is there any other questions from the audience? Right. If there is no more question, I think we will conclude this session. Angela, once again, thank you very much for your time, for your presentation, which is very insightful to help us understand how we can use process mining and Celonis for our teaching and research as well. I would like to also say thanks to all participants, so that you already made this session live. For the final part of this session, we would like to invite you all to turn your camera on so we can take a photo together with Angela and also conclude this session. Is there any help from co-host that can help me with the photo session?
Yeah, sure. The operator is going to capture this moment, Miss.
All right, good.
All right, so we would like to count 1, 2, 3. Maybe all of the participants are required to activate the camera, so we're going to capture this with Ms. Gibbert, PhD. So 1, 2, 3. Once again, because we have these beautiful ladies in this session, I think it's going to be great to have, like, love hand gesture, something. Miss Gilbert PhD. Do you know? Yeah, that one. It's like, you know, a sarang hair in Korean style, or maybe what do you say? How do you usually show off your hand gesture, Miss Gilbert, in Germany? How is it? Is it like a love shape of the fingers, or?
I'm not sure if we have had hand positions like this. I think we would just wave, I guess.
All right, so we just wave. All right, so we just have to wave to the camera. So just like a signal to say hi. All right, so we're going to show it to the camera, everyone. 1, 2, and 3. That was very amazing and beautiful. All right, so we have been captured the session with all of the participants, but I think we're going to be focusing on to the moderator as well. What about that? All right, so the operator required me to required Ms. Kurniati PhD and also Ms. Gabriel once again to be on the camera, because I think it is one of the great sessions in which Ms. Gabriel PhD has already given us so insightful knowledge. So Ms. Gilbert PhD, would you please kindly be on the camera? So we're going to capture this once again to be with the moderator, Ms. Kurniati PhD. All right, so once again, because the operator is going to be focused on this two great ladies researchers here. 1, 2, and 3. Thank you so much, Ms. Kurniati PhD, for leading the session. Of course, Ms. Gilbert PhD also for the inspiration that you have given us here. And I do apologize if I mispronounced the name. All right, so Ms. Gilbert PhD, I hope it's not mispronounced.
No, you didn't mispronounce it. All good. Thank you.
Thank you so much. Well, thank you, Ms. Kurniati PhD and Ms. Gilbert PhD once again. Thank you, and have a nice day.
Thank you. Bye.
So, ladies and gentlemen, there was one of the amazing sessions. We learned something new, and we believe that after the previous session, we're going to have a more collaborative works to contribute for the development of knowledge, of course, in the global problems. So, ladies and gentlemen, after this, we're going to have a break, and we would like to encourage every one of you to return to the main room at 3:15 p.m. as we are going to have the third keynote speech by Dr. Richard Hawkins, and the titled Assurance Cases for Autonomous System. So don't miss this chance for grasping much knowledge from the prominent speakers. So therefore, we're going to see you again at 3:15 p.m. and have a great break, and we'll see you all again. See you. Good afternoon, ladies and gentlemen. Welcome back to the afternoon session of the first International Conference on Software Engineering and Information Technology, ICoSEIT 2022. With me, Yayan Hamida, your Master of Ceremony for today's session. So, ladies and gentlemen, we believe that you have gained more power to get ready for the next session, but on behalf of the committee, we would like to encourage every one of you to be on your most comfortable position as you are going to witness more amazing sessions ahead. So, ladies and gentlemen, in this session, we're going to have two main agendas. Those are the third keynote speech and the third parallel session. And on the parallel session, in the breakout room 3A, there will be the third parallel session on the track of information technology chaired by Mr. Aristio Hadikusumo, STMT. And in the breakout room 3B, there will be the third parallel session on the track of software engineering led by Ms. Veronica Evendi, STMT. So therefore, for all of the presenters for the third parallel session, we would like to invite every one of you to the breakout room right now. So, ladies and gentlemen, while for the main room, we're still waiting for Dr. Richard Hawkins to be with us here in the Zoom session, and therefore before starting we would like to once again encourage every one of you to be on your most comfortable position and prepare your coffee or your tea for this afternoon session. We believe you are going to gain more knowledge from this prominent speaker, and on behalf of the committee as well, we're going to remind all of you regarding to the instruction of this virtual conference instruction. So this conference is conducted to be in listen-only mode. So by default, all of the attendees are muted by the organizer, as the organizer would like to make sure this conference conducted smoothly and productively. Ladies and gentlemen, you are allowed to deliver all of your questions during the session by typing it on the questions box, and the moderator will read all of your questions to the speaker, of course. And might be limited duration for the question and answer session, but we would like to make sure all of your questions are delivered to the speaker. And we also would like to announce to every one of you this event is being broadcasted live in our YouTube channel. Please refer to Telkom University YouTube channel, or maybe you would like to share the link to all of your colleagues, to your workers, or maybe other people so they can refer and learn more knowledge from this event. Last but not least, ladies and gentlemen, we also would like to invite every one of you to kindly capture your moment joining the first ICoSEIT 2022 and upload it to your social media, of course, by tagging us. So, ladies and gentlemen, we're still waiting for Dr. Richard Hawkins to be here, but actually the moderator is getting ready for today's amazing session. But we're still waiting for, and be patient, stay tuned here. We'll back to you soon. and gentlemen, since the time zone differences between here, Indonesia and also United Kingdom, Dr. Richard Hawkins is having some, we're going to have him later on in the session. And I hope that every one of you still wait for here while you're enjoying your coffee, this afternoon session, and you're getting ready for the next session, of course, I believe it. So once again, we're still waiting for Dr. Richard Hawkins as we're having some time zone differences between here in Indonesia and also UK. So ladies and gentlemen, stay tuned there because we're going to see amazing and great session for the next one. So stay tuned. Ladies and gentlemen, good afternoon and welcome back to this afternoon session of the first International Conference on Software Engineering and Information Technology, ICoSEIT 2022. So we're very glad that today here in the session we already have our speaker right now, Dr. Richard Hawkins, with us. So ladies and gentlemen, we're having the third keynote speech. Is an amazing session which will be presented by Dr. Richard Hawkins from Department of Computer Science, University of York, United Kingdom.
Okay, good morning. I'm really sorry for being late. I had the time zone wrong. I thought I was talking at 9:15 UK time, but it was 8:15. So I'm really sorry about that, but I'll get on with my presentation.
No worries. No worries.
Yeah,
Doctor.
sorry. Okay.
All right, so Dr. Richard Hawkins, anyway, this session is going to be led not by me, but by our moderator. Is it okay if I would like to introduce our moderator first in the session? All right. All right, so here we have already with us here the moderator, Ms. Gia Septiana Wulandari, Dr. Richard. So she will be leading the session, of course, and I think there will be so many participants, and attendees who are curious about Ms. Gia Septiana Wulandari, or maybe some of them already know her, of course. So please allow me to introduce our moderator. Ms. Gia Septiana Wulandari, SSIMSI PhD, is a lecturer of Telkom University, and she gained her PhD in Computer Science from University of York, United Kingdom in 2021, and she focuses on graph program and graph knowledge development research field. And I think this session will be led by Ms. Gia, of course, a very interactive moderator and the one and only. So Ms. Gia, time's yours.
Thank you, Ms. Yayan. Hello, good afternoon all. Let me introduce myself. My name is Gia, as what Ms. Yayan said, and I will be your moderator for this session. So this session will be a talk from Dr. Richard Hawkins from Department of Computer Science, the University of York. His research field is in computer science, software, and also safety, where he is active in project Responsible AI for Long-Term Autonomous System. And he also had some publications, as you've seen in the screen. So today, Dr. Richard Hawkins will talk about the use of safety cases for the assurance of software systems by discussing how challenges may be addressed by describing approaches developed at the University of York through work undertaken and on the Assuring Autonomy International Program. Okay, we can welcome Dr. Richard Hawkins. Please. Time is yours.
Okay, thanks very much. Let me just share my presentation. Okay, can you see my slides okay?
Yeah, we can see it.
Okay, good. Okay, thank you for the introduction. And again, apologies for turning up late. So yeah, I'm going to talk today about assurance cases for autonomous systems. So this is based on work that I've been doing working in the Assuring Autonomy International Program at the University of York. So that's a research program funded by Lloyd's Register Foundation in the UK. And we're really funded to do research into the safety of autonomous systems. So we're looking at lots of different domains where autonomous systems is used and looking at how we can make sure that they're safe to go into operation. And that's really what I'll be talking about today. So, as I said, this talk is about autonomous systems, and there's lots of definitions out there of what we mean when we talk about an autonomous system. But I normally just like to keep it quite simple and think about an autonomous system as really being any system that's capable of taking decisions independent of human control. So of course that doesn't mean that we're necessarily removing the human completely from this. So systems might only do a subset of the tasks autonomously, and they have humans who also control other tasks. And humans might also still have oversight and monitoring roles where they're expected to observe if things are going wrong and then take over if necessary. So normally we think of autonomy essentially as being a scale that runs up to kind of fully autonomous operation, but could be somewhere in between that. And autonomous systems are starting to be used more widely, so applications in lots of different domains. And some examples shown on this slide of kind of some of the most common application areas. So obviously autonomy is there's lots of excitement about using autonomy for driving, lots of car companies interested in that. Lots of people looking at the use of autonomy in healthcare, ranging right up to things like helping surgeons to do operations, so autonomously doing some of that. Autonomy with things like drones being much more commonly used now for various tasks. Autonomy in factories, where they're potentially doing dangerous tasks that we can stop humans having to do by putting autonomous robots in. And a really big area actually currently is people looking at using autonomy in agriculture, and particularly in places like Australia, where you've got really huge, very expansive farms. Having autonomy that can do a lot of those tasks it really beneficial to agriculture. So autonomy really being used for doing lots of things now. What I'm interested in, and what I'll be looking at in this talk today, is particularly where autonomous systems are used to do things that could result in some kind of unsafe outcome. So yeah, in terms of autonomous systems doing unsafe things, you don't have to kind of try very hard to find examples of this, and where autonomous system safety is already a big problem. So in particular at the moment, there's loads of stuff in the news about safety problems with self-driving cars. So things like Tesla's, so they call it autopilot system that they have. There's been a number of really high-profile accidents around this, and it's not just autonomous driving, but there's loads of stuff out there about potential safety issues around autonomy. So to be able to address this safety challenge that we have for autonomous systems, we need to have a focus on safety assurance. So safety assurance is about us being able to demonstrate that a system's sufficiently safe to operate. And the key to this really is being able to provide an explicit and compelling safety assurance case. And I'll talk a little bit more shortly about what I mean by an assurance case. But what I would say is that I think that creating a safety case or an assurance case is even more important for an autonomous system because of the complexity of the system and because of the uncertainty that's associated with autonomy. But basically the reason that we're interested in this is because we want to understand what's different about autonomy. So what is it that's really different about an autonomous system compared to a more traditional software-intensive system that we've always had to deal with in the past? So I'd like to just have a little think about what some of those differences might be. So here's we have a diagram that I guess is trying to represent a traditional software system that we think about from a safety perspective. So a system has some sensors that sense what's happening in the environment in which the system's operating. And then based on that information that comes into the system from the sensors, the software will determine what a safe and effective response is. And then that's sent to the actuators of the system that implement that required response. And this, of course, is a continuous process. So as things change in the environment, the software determines whether we need to have a new response, and then that's enacted and so on. But in a traditional software system such as the one we're representing on this diagram, although the response is implemented by the machine, so it's implemented by the software, the decision on what to do, so what the safest course of action is, that's essentially made by a human who's the person who's designed that into the software. So in traditional software systems, the machine isn't really making the decisions, not in any meaningful way. So the software is simply implementing a predefined response that's been created by the human. So what happens when we move to an autonomous system is we expand that role essentially. So we're starting to move the machine into areas that were previously reserved for a human, whether that be a human operator of the system or a human coder who's encoding the response of the system into the software. And with autonomy, these responses that we want from the system, they're not necessarily hard-coded in. And in order to be able to do that, the machine has to, for itself, understand what the situation is. It needs to then create some kind of accurate model of the world in which it's operating, and then generate a set of possible options that it has, given the understanding that it has of what's happening in the system. And then the machine itself has to decide between those options in order to achieve the system's goals within the constraints that it has. And of course, those constraints will include safety. So we've now essentially, with an autonomous system, extended this simple model that we had for software by adding in these extra understanding and deciding elements to that model. And this simple agent model that we've got here, this is one that we've found really useful when we're thinking about safety of autonomous systems. So we'll come back to this model later as well. So in the work that we've been doing as part of the AIP, which is the program I'm working on at the moment, we've been developing approaches for safety assurance of autonomous systems. And for that, what we need is a process that provides us with evidence of the safety of the system. And for autonomous systems, what we need to think about is assurance of the autonomous system as a whole. So as well as the assurance of these different agent elements around sensing and understanding and decision-making, we also have to consider the safety of the whole system. In addition to that, a lot of those elements of that agent, so understanding and deciding, for example, they'll often include machine learning. So we have to think about how we deal with the safety of that as well. So we've developed approaches around all of these areas. So you can see here at the top, we've got SACE, SACE, and that's the process that we've developed that deals with the safety of the overall system, operating in a very complex environment. We've got SAUS in the middle. Source deals with assurance of the understanding part of the autonomous system. And we've got SADA, SADA, and that's the process focusing on safety of decision making. But in this talk today, what I'm going to focus on is the safety of the machine learning. And for that, I'm going to introduce to you the AMLAS process, which you can see at the bottom here. So that's assurance of machine learning in autonomous systems. But as I start to talk about machine learning, I think one important thing to remember is that those ML aspects are just one fairly small part of that much larger kind of complex autonomous system. And that's why we need to put it all into this context of this overall agent model. So as I've already mentioned, what's key to the approach that we've developed for each of these bits is ending up with an explicit, compelling safety assurance case. So what I'd like to do now is just talk a little bit about what we mean by an assurance case and why we need to have one to reason about safety of the system. So when we carry out safety assurance activities, essentially what we do is we generate lots of artifacts that can be used as evidence to help to show that the system's safe. So, for example, we might have results of some analysis that we've performed on the system, such as fault-free analysis. We might have the results of some mathematical analysis that maybe we've done of our software, so we might have some formal analysis results. We might have lots of audit reports where people have audited and reviewed the processes that we've adopted in developing the system. We might have results from testing that we've performed. Might be some unit testing on the software, for example, or system testing that we've done. We might also have things about the evidence about the competency of the people who have been involved in developing the system and the software. So we might have, for example, things like training records that show the experience of those people. So what we essentially produce is lots of artifacts, and all of those things relate in some way to the safety of the system. And ultimately what we want people to be able to do, so based on those artifacts that we've created from those assurance activities, we want people to come to the conclusion that the system that we've developed is safe to operate. So we've got a load of evidence that might help us to do that, but that evidence on its own isn't sufficient for us to make a safety case. What we need to do is also make an argument. So when I talk about that, what I mean is we need to be able to explain why that evidence shows that the system is safe, because it might not be very obvious initially why all of those bits of evidence that we have come together to show that the system is safe. So in a safety case, we always need to have two parts. So we need that evidence. So we talked about the fundamental information that we have from which we can infer safety of the system. But we also need to have that argument. It's really crucial that we have that second bit, which is that explanation of how the evidence can indicate that the system is safe to operate. And obviously it's no good just to have the argument, because if we try and make an argument about why the system's safe, but we don't have evidence, that argument is unfounded. But also it's not good enough just to have the evidence, because if we have the evidence but we don't make an argument about that, then we haven't explained. Safety is unexplained. So we always have to have those two parts to the safety case. And what's really important when we're putting the safety argument together in our safety case is that we don't try to jump too quickly from the evidence to the conclusion that we're trying to make. So we're trying to carry the reader of the safety case along with us as we tell that story as part of the argument in the safety case, so they don't get lost as we're jumping from one conclusion to the next. So this picture at the bottom is trying to represent, in a good argument, we'll have lots of small steps that take the reader from the evidence to the safety requirements that we're trying to show are being met, rather than jumping very quickly from one to the other. Lots of small decompositions in the argument. So there's different ways in which we can try and represent these arguments that we need in a safety case in order to try and make those clear, so that it's easy for someone reading the safety case to understand why the system is safe. So one of the ways in which we can do this is you can use a notation called goal structuring notation, or GSN, which is the one you can see at the top here. And this is just a very simple notation for laying out arguments. So the rectangles represent the claims that we want to make in the argument. The circles are the pieces of evidence that can support those claims. And then we have other symbols that represent things like the context that gives the scope in which those claims are valid. And you can start to see here, although this is a really simple example, how rather than just going straight from the evidence to the conclusion at the top, we've put in these intermediate steps that try to explain to people how the individual bits of evidence start to tell a story that leads us to the conclusion that we want to reach. And there's other notations that we can use instead of GSN. So one is one called the structured assurance case meta model. So this is a standardized approach that's been developed by the object management group, the OMG, so the people who do the UML specification. And this, again, very similar to GSN, and you can see the same argument at the top represented at the bottom using SACM. Different notation, has slightly different ways of representing things, but essentially they're all trying to achieve the same thing. They're trying to show how the evidence you've generated supports the claims that you make about the safety of the system. Okay, so having talked about safety cases, I'd like to just move on now and think about one example in an autonomous system where there's real challenges around how we go about creating those safety cases that we'd like to do. And that's where we're using machine learning. So coming back to think about autonomous systems again, machine learning is really important technology, and it's very widely used in autonomous systems. So a lot of you, I'm sure, are familiar with machine learning, but just in case people aren't familiar with machine learning, actually, the basics of it are quite simple. So machine learning is the science of getting computers to learn by feeding them data in the form of observations and real-world observation interactions. So if we think about traditional software systems, they're created by writing a detailed specification, so what we want the software to do, and then turning that specification into code. And I guess one of the key differences here with machine learning is that ML doesn't require us necessarily to have that detailed specification. So, instead we've got software that's learning what it should do by looking at that training data. And of course, the ML model that we've created, one of the powerful things about that is that it's then able to respond to data that it hasn't seen before. So this ability for machine learned models to generalize to other data. And as we'll see, this makes it a very good approach for creating software for certain kinds of tasks that are really important in autonomous systems. So if we come back to our agent model again, what you'll have seen is that we already had machine learning identified on here. So ML can be used in both this understanding task, which we talked about being something that's really important for machine learning, building this model of the world around it, and also for the decision-making task. And ultimately, decision-making is what makes an autonomous system, this ability to make decisions. And ML could be used to help with both of those. Mostly currently, it's used around the understanding part. So, machine learning is particularly good for things like object recognition tasks in images and classification tasks. And both of those lend themselves very well to this understanding task that autonomous systems have to do, how to build this model of the world around you. So ML is used quite a lot in autonomous systems. But that can bring a problem when it comes to assurance. And the problem that we have really is that the traditional software safety processes that exist and that have been around for a long time for more traditional software, they're not really applicable when we're using machine learning. And that's because software assurance standards that we have traditionally have really been based on certain assumptions. So they assume that the software safety standards and processes we have assume that there'll be a decomposition of a software specification and software requirements. decomposed down to a detailed code level. And as we've seen with machine learning, that isn't what happens. We don't do that decomposition down to code. They also assume that we're able to interrogate the code so that we can do analysis of it. So people will actually go and look at the code and perform analysis. We don't have the visibility of the models that were learned, or certainly not in a way that we can understand them so that we can do that analysis. And also the traditional approaches to software assurance require us to be able to measure the coverage that we achieve of the code when we're doing testing. And this will be measurements about how much of the code space has been covered by running particular tests. Again, the fact that we can't really have visibility of the model precludes us from being able to meet those coverage requirements for testing. And actually the metrics that we use there don't really make sense anyway, since we haven't created lines of code in a traditional way. So all of that is kind of challenged by ML. So we don't have the detailed specification. We have this opacity in the models that we create, so we can't understand and interpret them. We've also got this problem that the traditional testing approaches for software assume that we can make assumptions about continuity between points in the test space, and with machine learning we can't do that. So 2 points in our input space might be quite close together, but actually could result in very different model outputs. So we have to start to think about alternative ways of assuring rather than falling back on the traditional methods. And that's really where the AMLAS process comes in. So what we've done is identified that there was this need to fill this gap for how we assure machine learning, and we created a process, assurance of machine learning autonomous systems. And you can see on this slide a kind of overview of that process that we've created. So we've got 6 stages to our assurance process, which you can see across the middle there. And these stages of our assurance process, we run in parallel to the development of the ML component that we're interested in. So it's kind of quite important, that idea that we're not developing our ML component and then we're trying to do safety assurance at the end. What we're doing is we're integrating the assurance activities that we're doing for machine learning into the ML development process itself. So we start with some system safety requirements. We work through these various stages of the AMLAS process. And then at the end, we'll end up with a safety case for that ML component. And in order to enable us to do that, we've described a process for each of these stages, but also what we've provided is a safety argument pattern. And what that does is lays out the structure that we would expect the safety argument to have for each of those stages of the ML assurance process. So looking at that importance of having that argument structure, we're not just telling people how do you generate the evidence, we're telling people how you then turn that into a compelling argument you can use in a safety case. And that's really one of the kind of unique things about AMLAS, and I think one of the most important things. So on the left here, this is showing one of the stages that we have in AMLAS has 3 different activities that you need to perform, which are the pink boxes across the middle there. And then the white bits are the artifacts that are kind of generated from performing those activities. So if you work through the process we've defined, you'll generate some activities. And then on the right-hand side here, you can see, so this is some GSN, like we saw earlier. Well, what we're doing is explicitly showing how the artifact you create for following the process on the left-hand side then gets used as evidence or context for the argument on the right-hand side. So this makes it very easy for someone to create a safety case for machine learning by following through the various steps that we describe as part of the AMLAS process. So I'm just going to talk through very quickly, really, a few of the stages of MLAS, just to give you a feel for the kinds of things that we talk about as part of that. Obviously not going to have time to talk through the whole thing, but I'll tell you where you can find out more at the end. But if we just start by looking at this first stage, which is the safety assurance scoping. So this stage only has 2 activities. So in that respect, it's quite simple, and those are shown here as the coloured boxes in the centre of the diagram. But this stage, despite that, is really crucial because it defines the scope for the whole of the safety assurance process and for the safety case that we're creating for the ML component. And you can see the final activity of this stage, as for all the other stages, is to create the relevant part of the safety assurance argument. And that's the bit that we provide the pattern or the template for that can be used. So there's 3 things that we really need to be able to define in order to start creating the safety case. So the first one is the system operating environment. So that's the environment in which our ML component is going to be used as part of some larger system. We need to define the system safety requirements, and we need to have an understanding of what the system architecture is. So firstly, understanding the operating environment in which the ML component is going to be used. So here we're thinking about an example for an ML component that's used in an autonomous car to detect pedestrians that in camera images. So the operating environment that we're having to consider here is really complex. So we're having to characterize the road and the vehicles, but also the people that might be present in those images, the lighting conditions, and so on. And one of the challenging things here is that for open contexts, such as we have here with urban driving, we simply can't model everything. So we need to try to understand what's really important, and also understand what we can leave out, because if we try and include everything in there, the space that we have to work with just becomes far too big. So the level of detail that we include in the model of that operating environment is really important, but we have to capture the key features that we need to be able to use to create the model that's safe. We also need to know what the safety requirements are that have been allocated down to the ML component, and that will have come out of the higher level system safety process that we'll have undertaken. I've just skipped on one. There we go. So at this stage, safety requirements that we have will be independent of any kind of machine learning technology or metrics about machine learning. So these are just requirements that reflect the need for this component to behave safely as part of some overall autonomous system. And that will be regardless of the technology that we choose to use. So these system level requirements that come out of this process, they'll be then turned into specific ML safety requirements in the next step. So we're essentially viewing an ML component as a black box at this point. And in this example that we've got for the autonomous car, what we're doing is specifying that when the vehicle that the ML component's used in is 50 meters from the crossing, the component has to be able to identify pedestrians that are on the crossing and identify them in their correct position. And this same requirement, even if we weren't using machine learning, if we were using more traditional software, we could still apply this same requirement. So there's nothing here yet that's specific to ML. So we also have to understand how the ML component fits into the larger kind of system architecture. So the ML component that we're thinking about in this example is just one small part of a really complex self-driving car system. So the ML component is part of object detection that you can see highlighted in the bottom left there. And that itself is part of a subsystem to do with overall detection. And that's part of then the larger perception subsystem. which you can see is itself part of a pipeline that runs from sensors to actuators that actually ensures that the car can drive itself. And understanding this architecture and the role of the machine learning as part of this complex architecture, again, that's crucial to understanding what safety means for that ML component as part of this overall system. So as we've already talked about, what we're doing is showing how the artifacts that we create link into the safety case, and we do that by providing the argument pattern for each of these stages, as you can see here. So I'll just briefly talk about stage 2, which is focused on taking those system safety requirements that we've already identified and then developing some specific ML safety requirements. And this is probably one of the most challenging bits of the whole process that we've put forward, but also one of the most important, because if we get this wrong, then everything we do after that point is also going to be wrong from a safety perspective, because we haven't properly defined what the safety requirements are. So here we can see how we're using the information that we generated at that first stage to help us to specify some meaningful ML safety requirements. So what we're doing is translating potentially quite complex real-world concepts and information about real-world cognitive decisions into a format and to a level of detail that's amenable to our ML implementation and ML verification. So we couldn't just take the high-level safety requirement and expect to generate a good model from it. We have to do this translation. And we don't always expect to specify ML requirements that relate to both performance and to robustness. And I'd like to think just a little bit about what we mean by those two kind of properties from a safety perspective. So performance requirements, they're really considering quantitative performance metrics that we can use. And that might be things like classification accuracy. Now, one of the things that we know here for safety is that rarely is there a single performance measurement that we can use kind of in isolation. So for a classifier, for example, what we'll often have to do is define an acceptable trade-off between false positives and false negatives and try and relate that back to what does that mean in the real world. So in terms of the example we have, we need to think about how these metrics relate to the real world effect of those in terms of stopping at the crossing before we encounter a pedestrian. We also need to have robustness requirements. So robustness, what we're talking about is the ability of the model that we create to perform well when the input that it's encountering are different to but similar to those that were present in the training data. So a useful approach that we can use here when we're defining robustness requirements is considering the different dimensions of variation that we have in the input space. So we were talking earlier about understanding the important features of the operating environment. We can use that information to translate into robustness requirements. So, for example, here we're talking about making sure that the model performs over the different lighting conditions that the vehicle might encounter when it's in operation, and also thinking about things like the different poses that pedestrians might have. And all of this becomes really important when we start to define the data sets that we're going to use, because this will be used to judge whether those data sets are good enough or not from a safety perspective. And again, if we follow the process, generate the artifacts, we can instantiate our argument pattern, which will become part of the safety case. So I'm aware I'm a little short of time. I'd just very quickly like to talk a little bit about data management, which is the third stage. And this is about generating data sets that are sufficient to enable us to create an ML model that satisfies those ML requirements that we defined as stage 2. And firstly, what we've required here is that we have a specification for explicit data requirements, which is something that often won't be done as part of a standard ML process, but is really important if we're going to build an assurance case for this. And then that's followed by the generation of data sets in accordance with those data requirements that we've laid down. And as part of the AMLAS process, we identified 3 distinct sets of data: development data, internal test data, and verification data. And I'll talk a little bit more about those in a second. And then we have to analyze those data sets in order to validate that they're sufficient to meet the requirements. So the ML data requirements are trying to specify the characteristics that the data that we collect has to have to ensure that we can create a model that meets the safety requirements. And here we've put down 4 different properties that we're saying data should have if we're going to create acceptable models. So relevance, completeness, accuracy, and balance. So relevance requirements are specifying the extent to which the data has to match the intended operating domain. And this is particularly important because data is obviously quite expensive to collect. So what we'll often look to do is reuse data sets. And that's very standard practice. So we need to be able to make sure that the data that we're using is relevant to the specific system that the model's being created for. So example here on this slide is a data set of German road signs. And this is the kind of thing that you can get as an open source data sets. And it could be really useful for lots of kind of automotive applications. But really important to consider whether that data set's relevant to the particular problem that we're trying to create a safety case for. So for example, in the UK, a lot of our road signs actually look quite different from some of these. So lots of things that are here in the images won't be relevant in that case. And obviously we have some signs here that wouldn't be present in that data set. So there's lots of questions that we need to be asking about the relevance of data, and you can see some of those shown on this slide here. Completeness requirements are specifying the extent to which data has to be complete with respect to those different dimensions of the operating domain that we talked about before. So thinking about those variation that could have in the operating domain that we'll have captured in the ML safety requirements, or that are defined by our description of the operating context. We can see here how that might include things like weather conditions, and this is some work that has been done on augmenting the data that you have in order to increase the completeness of the data set. So here they're taking one image and then using a technique that allows them to add in different weather conditions and different lighting conditions to that one image. So from that one image, they actually end up with 5 different data points that cover different features of the operating space. So balance requirements are specifying the distribution that's required in the samples in the data sets. So we're really thinking here about how the data is distributed across the different classes that we have. So there's a simple example here on the right-hand side. This is for a patient data for that might be used to train a model for doing diagnosis for some kind of medical condition. And this data would be unbalanced because we've got far more data samples for men than for women. And of course, what that might mean is that if we train a model using data like that, then the model might perform much better for when it's diagnosing males and females. So we have to be really careful that, as well as having completeness in our data sets, which we kind of have here, that we also have the right balance as well. We also need to have requirements on how accurate the data needs to be. And quite often this will relate to things like labeling of data samples. And this can be a particular source of error because that's often done manually because, you know, it's a difficult task. It's time consuming. It's tedious. Often people will outsource that kind of work, and so they lose control over it. So being able to ensure that you can check the accuracy of the kind of ground truth in your training data is really important there. So we then have to generate data that satisfies those data requirements that we've just defined, and talked about these three different sets of data that we'll develop. So we use the term development data in the AMLAS process to include training and validation data. And this is the data that we use to create the model, essentially. We then got internal test data, and this is data that's used by the development team to test the models that they've created and to help them to select the best model to use to deploy into the system. And then finally, we have verification data. And this is data that is gathered with the aim of essentially trying to see if we can break the models. So this is the data set that's least likely to be created as part of a standard machine learning lifecycle. So everybody has development and test data, but having this set of verification data that's actually created to try and test the models to breaking point is something that is really important as part of the assurance process. And it kind of requires a different mindset for the team that's collecting the data for verification. So normally you're focused on collecting data that allows you to create the model. What we're doing with verification data is trying to find realistic ways in which the model might fail when it's used in an operational system. So we'd expect a good verification data set to particularly focus on kind of challenging conditions, which are within the operating domain of the autonomous system, but which might cause a particular problem. And sometimes people refer to these kind of things as edge cases, really tough conditions that the model might have to cope with. One thing that's really important is that the information about the verification data is hidden from the developers, so that we can make sure that the models that are generated are robust to a whole class of failures and not just specific examples that the development team know are present in the verification data. So we don't kind of want to show people the exam paper before we give them the exam. Okay, and again, as for the other stages of AMLAS, we created an argument pattern that can be used to create a safety case. Okay, so I won't go through the rest of the AMLAS stages because I'm already running over time. But basically, if you're to follow through the whole of the AMLAS process, generate the required artifacts that AMLAS asks you to create, you'll be able to instantiate the safety case patterns that we provide for the ML component. And the safety case, the safety arguments that we generate at each stage of the AMLAS process then come together to create an overall safety case for the ML component. And you can kind of see here illustrated how they all fit together. So different colors on here represent parts of the safety case that relate to the different stages of AMLAS process. And then this safety case for our ML component can then be used as part of the overall assurance case for the autonomous system that we're interested in. Okay, so AMLAS has been around for a little while now, and we've been working on some case studies where we've been applying AMLAS process to different systems. So recently we've created a publication which we've submitted to a journal, but it's available on archive at the moment if people want to have a look at an example of applying the whole AMLAS process, all 6 stages end to end, and creating a safety case for an ML component. And I think this is the first example that anyone's done of what a safety case for an ML component is in this paper. And this was an example we did where the system is software that's on board a satellite and is looking at images from the ground and is trying to identify wildfires. So currently, when satellites are used for wildfire detection, they send all of the images back to the ground, and then someone on the ground has to analyze those images and work out if there's a fire in those. And that's obviously time consuming, but also it uses a lot of resource, which the satellites don't really have. So it's not a very good way of doing it. So instead, what this case study, we're working with a company that's developed a neural network that runs on the satellite itself, and that will autonomously identify if it thinks there's a wildfire in any of the areas the satellite's passing over, and it will raise a fire alert and send that back to the ground with the location and size of the fire, and then the emergency services can decide how they want to deal with that. And yeah, so on the right-hand side, this is the kind of images the neural network was handling. So the left-hand column is the original images that were coming into the satellite. The middle is the output that the machine learned model produces, which is like a masking of where it believes there's fire. And then the one on the right-hand side is the two overlaid, which we were using for part of the verification process. So that's a really interesting kind of end-to-end study of how AMLAS is used and how it creates a safety case. So if you want to know more, this web page here has AMLAS as a full document. So it is quite a long document that covers a lot of stuff. So you can read the PDF. We've also created a kind of more interactive version on a website that you can kind of search and click through, and that's also available there. What we've also done is, we're interested in having a tool to support this, because there's a lot of artifacts to manage and managing all the production of the safety case. So we developed a kind of prototype of what that tool would be, which allows you to integrate these artifacts together and actually starts to automatically create some of those safety argument structures for you. So developing the safety case as you work through AMLAS. So it is just a prototype, so it's been developed as a plugin for Microsoft Visio, but we're hoping to turn that into a proper tool shortly as well, working on that. Just one final kind of thing before I finish, in terms of where we're developing AMLAS going forward. So AMLAS currently is looking at how we create the safety case for an ML component prior to it going into operation, so pre-deployment. What we're now starting to look at is how do we carry on the assurance process once the autonomous system is in operation. So if things start to change during operation in ways you haven't anticipated, how do we ensure that we've still got the assurance that we require of the system and of the ML component? So we started to look at developing a process that kind of does the right-hand side of this picture, which is how do we monitor and understand the impact of changes, and then reapply some of that assurance process in order to ensure that the safety case remains valid during operation. Okay, so basically what I've been talking about today is some of the unique challenges that come because we're using autonomy, and particularly because we're making use of technologies like machine learning. And what they do is mean that a lot of the established approaches that have been around for a long time around how we do safety assurance, they don't necessarily work very well anymore. So what we've needed to do is look at how we can update those assurance methods so that we can start to address some of those challenges. And I've given you a flavor for what we've done in that space for machine learning. We've also done similar things at other levels within that assurance system, autonomous system. Because we've got such complexity in these autonomous systems, and because of the amount of uncertainty that comes associated with the use of things like machine learning, creating an explicit and compelling safety assurance case becomes even more important, so that we can explain to people how we're dealing with that complexity and how we're dealing with that uncertainty, and how we can show that the system's safe to operate. And as you've seen with AMLAS, it's the first practical guidance really that's been produced on how you can do this. So how can you create a compelling safety case for an autonomous system? Okay, so I'm sorry, I know I've run over my time, but hopefully that's not too much of a problem. So, but that, yes, I'll finish there. Thank you very much for listening.
Okay, thank you very much, Richard, for your talk. That's a very interesting talk. And now we'll enter the question and answer session. For participants, if you have any question, please feel free to raise your hand or submit your question in the chat box. Yeah, Mr. Nungki, do you have any question for Richard? Yeah, Mr. Nungki.
Okay. Thank you, Ms. Gia, and thank you, Richard, for the interesting presentation again. Actually, I hope this is a good way to introduce the concept of assurance case in our community here. Since I also teach the introduction to assurance case for undergraduate software engineering program here at Telkom University. And yeah, I hope the student will get more insightful talk from you. Regarding your presentation, I have a question related to the adoption of AMLAS in the context of fire detection with the satellite, as I mentioned before. It is about the how do you ensure that the adoption of AMLAS to the development of the assurance case is still relevant, since the data may be changing over time, and do you need update the assurance case in this context, or what kind of approach do you use to tackle this issue? Thank you.
Yeah, so I think this really relates back to the importance of that first stage about defining the scope and understanding and modeling things like the operating environment. So what we're essentially doing there is saying the assurance case that we put forward is valid within certain parameters, and that will be defined, for example, around the operating domain, around the types of functions that the component is being used for. So what we're not doing is assuring an ML component and saying it is now safe to use any way you like, to do any task you like. What we're doing is saying there's very precisely defined scope or context in which that's valid. Now, with machine learning, it has this ability to generalize. But that doesn't mean that you can take a model that's been trained on data and it'll just generalize to anything. What we can do is make claims about how well it generalizes within a particular scope. So that's what we've done with the wildfires. So we were very particular to understand different features of what was present in those images that might affect the ability of the ML model to detect fires. So like the type of land that it was being covered. So is it agricultural land, or is it grassland, or is it, and so on. And there were certain ones of those that we said were in scope and certain ones that were out of scope. Different sizes of fires. So obviously with these satellite images, fires below a certain size, really, really hard to see. So we were having to bound that as well and say, well, we're only going to, it was above a certain size. I can't remember how big it was now. Different levels of cloud cover, because that obviously affects the ability of it to distinguish the fire, because it can see to a certain extent through cloud because it sees outside the visual range as well. But if you've got really dense cloud, it becomes very hard to see and it affects the performance. So there was all these different variables. We had about 8 different features, and then within those we had the different range of things that we were training the model to cope with, and things that we said were out of scope. So the whole assurance case for this was built around those set of assumptions and getting evidence that it would perform within that. What we then have to do is make sure that we're not using it outside of that, because we don't have any assurance outside of that. So if we took it to somewhere that was an urban area, for example, performance of it doesn't have the performance we would need over urban areas because there's too many false positives and stuff. So when we're operating the system, we have to then be clear that the assurance case is only valid if you're within that context that's defined. But the good thing about the assurance case is that it forces you to be very explicit about what that context is. So things like GSN, SACM, those notations require you to say explicitly what are your assumptions, what are your context, and you need to be checking at operation that you're not doing anything with your system that takes it outside of that and invalidates the safety case. So sorry, that's a very long answer, but hopefully that.
Okay, thank you, Mr. Nungki, for your question, and also Mr. Richard for your answer. For participants, is there any other question you have? Please raise your hand if you do so. And I am actually interested as well in, because autonomous system is very a lot these days, and of course the assurance case become very important. Maybe it's a general question, but I am interested to know if there is any regulation about safety case in the UK itself.
So it depends on the domain. So some domains, they do require safety cases. So for example, in healthcare, they are very keen on safety cases. In the rail industry, like safety cases. Nuclear industry requires safety cases. A lot of the military standards, they specifically mandate the use of a safety case. But then you've got other domains like automotive, where they don't require you to have an explicit safety case, for example. I think that will have to change. So I think as the technology becomes more, as we have more autonomy and we have more kind of complex functionality and more uncertainty, I think we will need to, the domains that haven't yet embraced safety cases are going to have to do it. And I think they already realize that. And they realize that they need to get better at doing it. So, yeah. So it depends really which domain you're in as to how much they're already used. Yeah.
Thank you for your answer. And yeah, Mr. Nungki, do you have any other question?
I think he said yes in the chat.
Please unmute your mic. Okay. For the host, can you please unmute Mr. Nungki?
All right. Thank you. Sorry, Richard. It is very interesting here that since you mentioned that the awareness about the assurance case or safety cases in context of the from the government's perspective, I know in the UK they're really aware that I mean the importance of assurance cases when you build the, for example, autonomous system or things like that. Like the nuclear domain, medical, and so on. And some countries, as far as I know, like Indonesia or Japan and also Singapore, already adopt the assurance case concept in the context of their government in the country. And I just curious, what do you have in mind, or what is your suggestion to raise the awareness that the importance of assurance cases in yeah, for example, like the nowadays where we have the autonomous system everywhere in our daily life. Can you please speak something about the importance of assurance cases to help us in the autonomous system era? Thank you.
Yes, sorry, can you just repeat? I missed an important part of that. What was your question?
I'm just asking your opinion. How do we raise the awareness, the importance of assurance cases, in this context? Thanks.
Yeah. Well, so I think so. It's certainly in the UK, the approach we've been taking is to try and influence regulators. So we've been doing a lot of work around, so key people, for example, in automotive, where we think there's a real requirement to move towards that. Trying to engage them with things like the AMLAS process, and showing them. I think having examples like we've started to develop with these examples of what the assurance case gives you, because I think in the past it seemed maybe quite an abstract concept, this idea of assurance cases, and especially as people are sometimes reluctant to share safety cases because they've got a lot of details in them that they maybe don't want to make public. So I think the fact that we're starting to produce examples of this is what an assurance case would look like for an autonomous system, and we can show people how that enables them to explain why their system's safe. I think it helps both the developers and the regulators. So if you're trying to move, so the alternative is that there's a very prescriptive kind of set of requirements. So the regulator will say, this is what you need to do, and you have to be able to do all of those things. And that's bad for the regulator, because it requires that the regulator tries to keep all of that up to date and reflects technology. And the technology moves much quicker than the standards can in terms of what's possible and what the state of the art is. But what it also does is it stops the developers from having the flexibility to do what they feel is best. Whereas with an assurance case, it's not mandated how you do things, as long as you can create some compelling argument at the end that demonstrates why that's the best thing to do. So it's giving the developers as well a lot of flexibility to use these new technologies to try innovative things, but not be told they can't do that because the regulations that were written 3 years ago said they couldn't do that. So I think giving people examples of how it gives them that flexibility and how it allows regulators it's almost putting the responsibility back on the developers to work out what the best thing to do is, and as long as you can create that compelling argument that says why you did it and why it's the right thing to do, you've got that freedom to kind of, embrace these technologies. Because one of the things we're trying to do on this program is we don't want safety to be a kind of hindrance to the adoption of autonomous systems, because autonomy can bring huge benefits. Yes. Talking about all those different domains before, I mean, it can be a real game changer in things like healthcare and agriculture and driving and stuff, But if safety is just coming along all the time saying we don't know how to assure this, or this is too difficult. Yep. So I think assurance cases are a way to kind of maybe get over that barrier and allow people to innovate, but in a safe way. And that's the kind of conversations we've been having with regulators in this country. And I think I've found that they're very open to hearing that, actually. Getting it into legislation takes a long time, obviously, but if they bought into the approach, I think that's really useful. So I think, obviously, we've done a lot of that in the UK. It would be good to see how we can kind of do that more globally as well. I think you're right that I think you said about how we're maybe already more familiar with safety cases in the UK, so we may be starting from a better place anyway. But I think almost autonomous systems give us an opportunity really to embrace them more widely.
Yep.
So yeah.
All right. Thank you, Richard.
It's a good question. Yeah. Thank you.
Yeah, thank you, Richard, and also thank you for your discussion. Unfortunately, the time is over, so we need to end the discussion as well. Thank you very much, Richard, for your talk, and also for participants. Thank you for your attention, and see you in the next session.
Thank you.
Wow, that was a very interesting session led by Ms. Wulandari PhD, and of course thank you Dr. Hopkins from the insightful session. And now we would like to invite both of you, Ms. Wulandari PhD and also Dr. Hopkins, to be on the camera as we're going to capture in this great session. All right, so would you please kindly give the sweetest smile? It's like an old friend reunion. I thought that we're going to give this sweetest smile to the camera. 1, 2, 3. All right, so Dr. Hopkins, I think it's going to be very beautiful morning in UK, right? So would you please kindly give your thumbs up to the camera as a sign that it's beautiful morning there. All right, so thumbs up. All right, so Miss Gia as well, because Miss Gia is currently so beautiful for having this session. 1, 2, and 3. All right, wow, that's amazing. Thank you, Miss Wulandari PhD, and also Dr. Hopkins for this amazing session. Ladies and gentlemen, the keynote session 3 marks the end of the first day of the first International Conference on Software Engineering and Information Technology, ICoSEIT 2022. On behalf of the committee, we would like to invite each and every one of you to attend tomorrow's agenda. There will be tutorial sessions, keynote speech, and of course conference awards, and also closing ceremony in tomorrow's event. So tomorrow agenda, we will discover the 4th keynote speech by Dr. Bassem Sulaiman from School of Computer Science, the University of Sydney, who will be talking about effectiveness and consistency of fact-checkers in the post-truth world, empirical analysis across social media platforms. And there will be also the 2nd tutorial session by Mr. Adam Darmanto from ID Cloud Host on cloud computing, tantangan dan peluang pengembangannya. There will be the 3rd tutorial session by Mr. Andi Sulasikin and Mr. Bahrul Ilmi Nasution from Jakarta Smart City, who will present about collect the behaviors from internet, web, and text mining using Vyton. And never forget, tomorrow there will be the announcement for the Best Paper Award of the first International Conference on Software Engineering and Information Technology, ICoSEIT 2022, and of course a very warm closing statement from our Dean of School of Computing, Telkom University. So therefore, ladies and gentlemen, we're looking forward to seeing you again tomorrow. And this marks the end of the first day. On behalf of the committee, I extend a warm gratitude to Rector of Telkom University, Dean of School of Computing, Telkom University, Chair of IEEE Indonesia Section, General Chair of the first ICoSEIT 2022, our patrons, Yayasan Pendidikan Telkom and Cloud Host. And of course, abundant thanks to keynote speakers, tutorial speakers, presenters, and attendees for all of your time and attention. And never forget to say good luck to all of the participants of the first ICoSEIT 2022. We hope you gain valuable knowledge, build stronger network, and of course develop future career. Before leaving, please allow me to quote a very beautiful words by Henry Ford. Coming is a beginning. Keeping together is a process. And working together is a success. We're expecting to reach the success together in impactful collaboration through the first International Conference on Software Engineering and Information Technology, ICoSEIT 2022. So I'm Yayan Hamidah, thank you, and I'll see you again tomorrow. Wassalamualaikum warahmatullahi wabarakatuh.